Alright everybody, welcome back to another Ask a Dev Unreal Engine tutorial. My name's Kevin. We are continuing our mini games series, and today we are going to be making a twin stick shooter start to finish. Now, when I talk about twin stick shooters, I'm talking about the classic twin stick shooter, things like Binding of Isaac, Enter the Gungeon, Geometry Wars, Nex Machina, Colt Canyon, Sleep Tight, take your pick. There's so many great examples out of them. Some of them get into bullet hell, some of them get into building even. There's even flying versions of it. But the overall point is that's kind of the goal for today. Now, there's some particularly interesting things about the twin stick shooter specifically, in the sense that when I first started in Unreal, there used to be a tutorial called Twin Stick Shooter. It was great. It was a start to finish tutorial, and it helped me really wrap my head around all of the pieces and bits of creating a game in Unreal Engine. That's kind of the point of these mini-series. This one, we're going to be taking a step back a little bit and even starting even more basic and trying to cover all of the various aspects of it with our classic success condition. So what do we need to build today? We're going to create a game. We need to have a hero character, and we need to be able to win the game. Seems basic. Our hero character, in order to win the game, needs to be able to shoot and clear enemies. So we need enemies. We also need to have a level, and we also need to be able to clear the level. We need a little bit of UI to let us know how we're doing. And with that, that also means we're going to be building projectiles. We're going to be building some very basic visual effects, and all of this in Unreal Engine 5.4. So we have an insane amount to do. Let's go. All right, so starting off, we are going to start off a little bit differently than we do most of our tutorials, and we are actually going to start with the top-down tutorial. And this is going to just be our base project, and I'm going to call this Twin Stick Mini Game. Now, even though we're starting with a template project, we are going to go on a quick tour of all of the pieces so you are familiar with how everything works, where everything is, so that you can follow along in Unreal. So first things first, before we even get into that, let's make a couple project changes. First thing is, down here in the bottom left is the content drawer. I like to dock this in the layout. Now, what is the content drawer? The content drawer is basically where all of your game assets live. And when I talk about those, I'm talking about your characters, your levels, everything that goes into your game gets organized into this content drawer. That's where we find what we're looking for. Generally speaking, the way the template projects are set up is you have your content, your characters, cursors. Fortunately, all this stuff is named, and then you have your top down. In your top down section, we have blueprints, we have inputs, we have maps. So let's talk a little bit about that. So blueprints, these are the things that we are able to use to create basically various aspects of our game. It works like a blueprint. If I create a blueprint to build an enemy, it's all of the information that the system needs in order for the enemy to work, for example. Now, same thing with our maps. This is where all of our maps are stored. Currently, right now, we have a top-down map. This is the world that our character is going to run around in. Now, before we get into making some changes and some more on the tour, I do want to make some project changes. So underneath our editor preferences, I come from a Maya background, so I need to flip the middle mouse button. So you are going to find what works best for you, and I believe for me, I need to invert this. Let me just double check. Yes, this is exactly how I like it. The other change that I like to make, also from a just again coming from another 3D package standpoint, is I like to enable the rotate. I like to enable the arc ball and the screen rotate, just in case we're manipulating stuff. As we go into other preferences, etc., I will let you know what those are. Now, generally speaking, when we open a template project, one of the cool things is it works right out of the gate. So let's just go ahead and see what happens when we play our game right now. And in order to play our game, there's a giant play button up here in the top. If we press play, you'll notice that our character is spawned. Now, this game is top down. It works a little bit differently than others. Wherever I click, that's where my character goes to. If I hold and click, the character basically follows my mouse. The reason we picked this particular template is because the camera angle and everything is already very similar to a typical twin stick shooter camera. So let's talk a little bit about how it is that this character is able to run around. So in our level, if we take a look at everything that's here, once again, a lot of this stuff is labeled very nicely for us. I'm over here on the right. This is our outliner. This is our world outliner. This is everything that makes up our world. If we take a look at this, we have a bunch of pillars. Fortunately, they're labeled. If we hide the pillars, you'll see they all disappear. So you can see which aspect of the game these pillars are. Same thing for these blocks. If we turn off the blocks, there you go. We have navigation. This is basically everything that goes into the navigation is how our character moves around, where they can go, what they can walk along. And a lot of this is built especially for enemies. And then one of the things that I want you to key on right here is a player start. We use this player start to determine where our character is going to begin when we press play. So look at where this player start is. When I press play, I'll be right between these blocks and the pillars. So here we are, right between the blocks and the pillars. If we want to move our player start, we can just grab it using these. This is gizmo. I'm moving this in X. If I go ahead and start now, I'm going to start much further back, closer to this wall, as an example. Okay? So now, what happens when we press play? Well, when we press play, Unreal Engine basically goes through a whole series of things, loading the level, loading the characters, and everything that happens. It looks at the player start and says, do I have a player? In this case we do, and if so, I am going to start my player in this position. Now, when we start our player, what actually happens is Unreal Engine goes and it looks and says, what is my default player for this particular game experience? And in this case, it is this blueprint for a top-down character, which is in our blueprint folder. Let's open that up and take a look at a couple things in here. All right, so our top-down character blueprint has a couple of key parts to it. And one of the reasons I'm showing you this is because we are going to be making edits in here. Now, from the standpoint of potentially previous examples you've looked at, etc., there's actually not a lot going on in the event graph here. And that is because a lot of that is in the player controller, which I'll get to in a second. The top-down character is basically the pawn. It's the thing that is controlled. It does all of the visuals for our character. In this particular case, if we look over here in the components, we have a mesh. This is our character's geometry, the skin, everything that is basically the visual display. You can even see here the character in the viewport is actually breathing because it's in idle mode. All right, we have this spring arm. This spring arm is our camera. This is where our camera is going to be relative to our character when our spawn. So when Unreal Engine starts our level, it starts the player start, it takes the camera and it aligns it to this camera location that we have set here for this particular character. We have a character movement component. This is what allows us to move. There's a whole bunch of logic and things like that that allow us to, at what speed, can we walk, can we run, can we swim? There's all kinds of stuff in here. The scale of gravity, all those things. We're not going to get lost in that right now. And then there's our capsule. The capsule is very important. When we move our character around, what we are moving is we are moving the capsule. And the visual of our character is just along for the ride. So as we press play and we start walking around with our mouse, what's actually happening is, if I show, let me see if I can show collisions and show you all. Okay, what's actually happening is our capsule, you can kind of see here, you can kind of see the, let me eject here and zoom in. Okay, you can see this capsule around our character. If I turn off the visual for this character by simply resetting the, let's see here, our mesh. Okay, over here, I'm going to clear this mesh. When I clear this, you'll see my capsule is empty. There's no visual for our character. If we come back in here, I'm going to move my player start back out in the middle just so I'm not by that wall. When I press play this time, you'll notice that I don't see my character anymore. But if we turn on the collisions again, you'll notice my capsules here. So as you look, you can see this capsule. It's very hard because of the coloring of it. You can see this capsule is actually still moving around in the level. So actually what we're moving, and the first level of collisions and everything that's happening is all being done with this capsule for efficiency, for speed, for performance, so that when you play, you're getting, you don't get hitches and things like that. All right, let's go back and add our visual backend. So back here in our top-down character, underneath the skeletal mesh, this is what is going to be displayed. I'm going to choose the Manny again, and we'll just go ahead and do that. Okay. So we are back to where we were, where we have our character able to move around. Now, how is this move happening when we click our mouse? I talked about the controller. You'll notice right next to my top-down character, there is this top-down controller. If we open this up, interestingly enough, the controller is what determines, are you using a mouse, are you using a gamepad, how are you doing that? So one thing to note, and I'm going to gloss over this really quickly, is we have this mapping context. What this is this is our input mapping context. What it does is it determines which keys are going to allow our character to move, what mouse clicks do what. If we take a look at it, just as an example, when I open this input mapping context, it's very easy to read. Here's all of our mappings. We have two of them only, and we're going to be working in this, which is why I'm showing you this. We have a set destination click and a set destination touch. What this does is it sets it up so that the controller can do something whenever we do a destination click. So what happens in here, if you're new to Blueprints, destination click gets called. This is visual scripting 101 stuff. This gets called and it goes through these execution pins and it does its thing. So in this particular case, on click, what it does is it finds the cursor location, and if there is an actual valid location, it goes ahead and it follows the cursor. Now there's two of these, one of these, four, and they're very well commented. So on release, if the input wasn't held, try to move to the location under the cursor. And this is if the input wasn't held, try to get to the location under the finger. Now we're going to be changing all this. Okay, let's see what else we need to cover in our tour. We talked about the controller. We talked about our pawn, it's called, or our top-down character. Now that we know where everything is and how it works, what we want to do is we want to be able to change this to work in a twin stick shooter manner. So the entire next section is going to be all about basically deleting a bunch of this stuff and changing our controls so that we can use our gamepad. So with that, let's get a little bit into how are we going to update the controls for the twin stick shooter. Okay, so to update the controls, here's what we need to do. Right now, this is based on where I click. I don't want the click to happen. That's not what I want. What I want is, I want to either be able to use WASD or the gamepad thumbstick to move my character. So I don't want it to automatically go wherever I click, but I do want the mouse stuff so that I can use that to update my aiming. So let's start disconnecting and reconnecting a bunch of stuff. I'm going to go into the controller, and what I'm going to do is I'm going to basically disconnect all of this stuff. And I could probably leave this here. Here's what we'll do actually. Here's what we're going to do. We're going to delete this from the mapping context. Okay? I'm going to save this mapping context. And what that means is the game no longer knows what to do when I left click or right click. But I'm keeping this in here as reference because there's actually some cool information in here that we can use when we build out our stuff. So if we press play, I have no way to move my character. I'm clicking, I'm WASDing, nothing's working. So let's go ahead and add in some WASD controls. So to do that, what we need, we've talked about the mapping context, that's what you're actually clicking on, but we do need another thing called an input action. So over here, we have basically these input actions are they're the placeholder for what you want to do. Move, jump, attack, shoot, in this case, set destination, click, etc. So what I want to do is I want to create a new input action. And this input action we are going to call IA move. And we're not going to do a whole lot with it. We'll just go ahead and keep this as our defaults. And then we're going to add this to our mapping context here. So what this does is it makes it so that we have an input action called move, and we need to bind it to a key. So in order to bind it to a key, I can click here and I can choose something from the key from the list, or I can just tap on this keyboard icon and click a button. So let's just start simple. Let's just get our character to move forward. So I'm going to press the W key. So now my character, or the input mapping, knows how to at least recognize when I press the W key. So now we just need to tell our character to do something with that. So let's go to our controller, and if we right click in here and we type in move, or actually let's just do IA move, you'll notice that after we've added that, we now have our input action for the enhanced input system for move. And when this is trigger, all we need to do is tell our character to move forward. All right, let's do that. So what we're going to do is we are going to have a left to right and a front to back. Much like if you've ever looked at the third person setups, it's almost exactly the same like that. So let's do an add movement input. Add, oh, actually we need to grab a reference to our controlled pawn. So let's get a self. We could probably move all of this into our pawn, but so let's talk about this a little bit. Right now we're in the character controller. So when I get a reference to self, what it means is the character controller. This is a reference to the blueprint that I'm in. So with this, what I'm basically saying is for this character controller, I want to get the controlled pawn. Now, what this is going to do is it's going to get this top-down character. For that top-down character, what I want to do is I want to add a movement input. So we're keeping this basic. So when we trigger this, we're going to go ahead and add a movement input. Now, the direction that we're going to go is going to be determined by the control rotation. So let's just get the forward vector. And let's split this pin. And let's get our control rotation. And I'm going to split this pin. And the reason I'm splitting this is because I don't want roll, I don't want pitch, I only want the yaw, because we're doing a top down. So think about it as which way I'm facing this way. Like if I'm in a swivel chair, I want to know which way I'm swiveling. I don't want to know which way I'm rocking or which way I'm pitching. Unfortunately, they're called roll, pitch, and yaw. So we're going to grab this, we're going to take this, and we are going to connect it into our world direction. Now, if we don't give it a scale, it is just going to always move forward at the same speed. Let's see what happens when we run this right now. Okay, so if I press W, our character moves forward. If I press S, A, or D, the character does not move in any other direction right now because we have not mapped those keys. So let's add a couple of little bits to our input mapping. So here we go. We have our W. That's great. We don't have any modifiers on this right now. And with that, we're definitely going to be talking about modifiers as well. So let me just double check. Do I want? Yeah. Okay. So when we actually make this work for the gamepad, we'll add a couple of changes. For now, let's just get WASD working. All right. So we need another mapping. This is going to be the S key. So I'm going to click on here. I'm going to press S. Now we do want a modifier on this one. And the modifier I want to negate. Why do I want to negate? If W is forward, S needs to be backwards, which is the opposite of forward. So in this particular case, now I have a front and a back. And if we take a look at our move or our top-down controller, it is going to take whatever the action value is and plug it in. We need to plug this into our scale. This is where we run into our first change that we need to make. Right now, our move is basically a digital boolean. Either it's happening or it's not. That's not really what we want. What we actually want is we want this to be a 2D vector. The reason we want it to be a 2D vector is because if you think about a thumb pad on your game controller, for example, let's see if I can get this up here. When you think about your thumbstick, you're pressing forward, backwards. That's one vector, because a vector can go forward or backward, left and right. That's the second vector. So this is a 2D vector we're going to be using with our gamepad. Okay, so now we have a 2D vector. If I save this, when we come back to our top-down controller, if I refresh this, actually I don't even have to refresh it, it just did it. It gives me an action value. And I can take this action value and I can split this. And by splitting it, you'll notice I get an X and a Y. In this particular case, I'm going to take the Y value and I'm going to connect it into the scale of my move. Now what this is going to do is, if I am pressing W, which is forwards, it is going to give me, let's just say, keep it simple, it is going to give me a +1. Okay? If I press in Y. If I press the S key, it's going to give me a -1. So it's effectively going to scale this. So now that we have our scales connected, we should be able to go forward and backwards, but we can't. Let's figure out what happened there. We have our scale, our Y value. Oh, maybe, oh, we didn't. Let's just check to see if it's actually, if we have our axes messed up right now. Yep. Okay, so right now, X is connected. So we probably want to flip this. And to flip this so that it makes sense logically, what we're going to do is in our modifiers, we are going to, over here, let's take this and add in a modifier. And this modifier is a little bit tricky. It's basically Swizzle. I don't know why they went with Swizzle instead of swap or switch or whatever. But now that we've swizzled that, let's go ahead and actually we may need to move the swizzle up one more. Hold on a second. Let me just double check. Yeah, we basically need to swizzle both of these. Okay, so in addition to the negate, we need to swizzle. So let's swizzle this. So this is basically switching our X and our Y values. So the idea here is, now that we have that done, when we come back, we should not be able to move front to back or left to right. That's because we swizzled, but we didn't connect properly in our controller. It cracks me up that it's called Swizzle. Okay, so Y. Now if we connect in our Y, we should have front to back now. Let's check that. So this is front, that's our W key, and this is S, this is our back key. Okay? So we basically, swizzling it, flip the axis so it makes sense. Y is up, that's what most people are used to. And by the way, Y is not up in world space. Let me be clear on this. If we escape out of here, what I want you to look at in the bottom corner, okay, Z technically, vertical in Unreal Engine is Z. But what I mean by Y being up is, from our camera, if I want to go toward the top of the screen, that's Y, and left and right is X. Also, that is how the gamepad is set up as well. Okay, so let's go ahead and connect in now our AD. So as part of our WASD controls. So we're going to need 2 more. We can just go ahead and create both of them. We'll just go ahead and click the keyboard and click A, and we'll go ahead and click the keyboard again and press D. And then our modifiers, we are going for the A, because A is going to be the negative. We're going to add in a negate. And then for the D, we are going to, should just be free and clear. So let's just see how this works. Save all. Okay, so we have our up and down, but we actually forgot to connect in our left and right. So this is up and down. We can comment this, or forward backwards. Let's call this forward backwards. This is going to be forward back movement. Okay, we also need to do left right. And it's going to work the exact same, except what we're going to do is, instead of connecting in the Y value from our axis, we're going to connect in the X value. So that's going to be our scale. That's going to be our scale. Also, you don't need to worry about, I just made it bigger so that you all can read it a little bit better. Okay, so now our X value is connected in, but we need to get which way we want the input to go. So this is going to be the left-right values of for our controller. So much like we did before, what we're going to do is we're going to get our control rotation and our forward vectors. But instead of our forward vectors, we're not going to get our forward vectors. We're going to get the right vector instead. So let's just paste this in. Let's get the make some room here. Let's get the right vector. Here's our right vector, and we're going to split this. Now this one, we do want the X and because we're getting the right vector, we want the roll and the yaw, and we're going to connect that in. So this gives us our right to left. So let's just double check and see if we got that right. So front to back still works. That's great. Left works and right works. That is it, y'all. We have just successfully connected WASD. That's great. All right, now we do need to make a couple of slight changes because we want this to work for our controller. So let's go ahead and show you real quick how to add the exact same thing to our controller and why the enhanced input system is so awesome. Because what we can do here is in our mapping context, all we have to do is add in a new option here, and that is going to be our game left thumbstick. So this one I am going to type in. It's game left thumbstick 2D axis. All right. And what I want to do with that is I want to show you what happens now. This should just start working. All right, so we press play. Now it's not going to work right away. I have to click to activate the window. Okay, now when I activate the window, now I can use the thumbstick to move our character around, which is pretty cool actually. But there's a problem. Here's the problem. When we're done moving, watch what happens when I take my thumb off the stick. Why is the character still marching or walking or doing whatever they're doing? The reason is because on a game controller, or lots of different controllers depending on the type of controller it is, even though this thing is not moving, there's a slight area in the middle where it's kind of getting a little bit of input still. It's almost like it's slightly engaged, even though I've let go of it. This is called the dead zone. The dead zone determines how far you have to press before your character starts moving in a particular direction. Right now, we have no dead zone. So it is super sensitive, and when I let go, it doesn't actually stop. So we actually do want a little bit of dead zone in this case. So let's go ahead and add in a quick dead zone. Once again, our enhanced input system makes this easy. So I'm going to add in a modifier here, and that modifier is going to be the dead zone. Now, if I just use the default values, you can customize this. You can even make this customizable for your game and your players. But if we go ahead and press start and we click play, now when I move my character around like before, that's great. And when I let go, you'll notice the character stops. The character doesn't actually start to move until I get at least some amount of pressure on the thumbstick now. So we actually do want a little bit of dead zone. And again, in most games like this, you can actually customize how much dead zone's there. But that's what it's for. Now you know. Okay, now we have a new thing that we want to take a look at. You'll notice, so we basically have all of our input set up. We have WASD working, we have the left thumbstick working, that's great. But for a twin stick shooter, what we need is we need our character to not turn to face the direction of movement. We want the character to face wherever we're aiming with our mouse. And this is where we get into the mouse cursor stuff that we started with earlier, and that's why we're using the top-down template. So what I'm specifically talking about is when I press forward, notice where my mouse is over here. It's pressing forward, the character is facing forward. I want this character to face where my mouse is, not where I'm WASDing, because this is where I'm going to be shooting. So in order to do this, let's first disable that feature. So in our character top-down character, I believe it's rotate. There is an option, and you're going to find in your experience that a lot of Unreal Engine is finding the magic checkbox. So in this particular case, for our character, there is an option here that says orient rotation to movement. And what that means is if the character is moving forward, it's going to orient the character to face forward. We're going to turn this off. Now I found that in the whole details, but generally this is under the character movement. It makes sense. That's where this happens. So if I uncheck this now, what I want you to notice is when we play, if I go forward, back, left, right, you'll notice that my character is always facing forward, no matter what I do. This is what we want for a twin stick shooter. It's absolutely what we want. But what we need to do is we now need to add in the mouse component to get the character to look at where our mouse is. So let's do that. Over here in our top-down controller, this is where we put all of our front to back, etc. This is also where, if we look at it, this is where they were getting the location under the cursor. And with that, if it was valid, they were basically setting follow mode. We're going to use the exact same kind of thing. Now, how does this work? If I double click on this, what I want you to note is this is actually what's happening. This is what's called a function. If we come back here, this get location under cursor is a function. A function is a group of blueprint scripting that you can reuse all over the place, and it helps keep your blueprints clean, and it helps organize it, and it also is really great for making things more reusable. If you want to go into a deep dive into blueprint functions and how this all stuff gets used, I'll throw a link up here so you can take a look at that. But what's important from this is we are getting, this is a actual function that it was created by a developer somewhere called get hit result under cursor by channel. What this is going to do is this is going to give me a location underneath the mouse cursor that I can then use to look at, which is what we're going to do. So let's just grab these. I'm going to Control C. This is great about Unreal. You can Control C, Control V, a lot of stuff, including your blueprints. And what I want to do is we need to make it so that our character will face the mouse. So in our event graph, let's go back to our event graph. What I want to do is let's go ahead and we're going to keep this same kind of functionality. Yeah, actually, let's just reuse all of this. So I'm changing the plan here a little bit. I'm going to take all of this. Now, first we have to figure out when we are going to look at our mouse. Are we going to do it when we click? No, because we want click to be able to shoot. Also, we want to be able to look around independent of whether or not we're actually holding our mouse down the whole time. We actually need this to happen all the time. So for something to happen all the time, it's important to understand what's going on in the background. When the game starts, time is moving forward. And you can think about it. As time moves forward, the clock is ticking. Tick, 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 tick. So as time goes by, there is a concept in Unreal called tick. What that actually refers to is each tick of the clock do a thing. Okay? Almost everything in Unreal, or a lot of things in Unreal, can tick. And your characters actually tick. So what happens is each tick of the clock, Unreal goes in and as fast as possible updates all the visuals, the bullets, the collisions, everything that's going on, the animation, all of it's happening on tick. That's what tick is. So what we're going to use is we are going to use the tick for this controller in order to always look at where our cursor is, so that every time the clock ticks, the character will turn to look at the cursor. So let's just go ahead and do that. In order to do that, if we right click, we can add an event. This event that we are going to add is the tick event. Okay, now just to show you how this works, if I put a print in here, this is another function that you can use. I'm going to print something called hello. If we just press play, you'll notice in the left side, it's just printing hello over and over and over again. This is happening because every time the game ticks, it moves forward in time. One frame, one tick is the best way to think about it. It prints hello now. Okay, but rather than printing hello, what we want to do is we want to get the location under our cursor. Okay, so this is getting where our cursor is on the map, and it's taking that location and it's putting it in this variable. Now, a variable, wow, there's so much to go over. Okay, so a variable is a storage container. It's like a bucket that remembers the value. There is an entire video series on how variables work. So if you want to dig more into that, go ahead and follow that link. It is probably good to have at least all the fundamentals out of the way. Otherwise, you know, these can get pretty deep. So variable stores a value. In this case, we are storing the cached destination, which is where the mouse cursor is currently. Okay, so now that we have our cached destination of where we want to look at, what we need to do is we need to tell our character to actually look at that point. So one thing we can do with that is if we get the controlled pawn, this is, if you recall, right now the self is the controller, the controlled pawn is the character that we're controlling. What I'm going to do is I'm going to get that actor location. So this is the current location of that control pawn. And then what I can do is I can take this destination and I can find the Lookat rotation. So this is a nice little helper function that somebody wrote for us. One of the developers wrote for us. So we're going to get a rotation out of this, which is great. Now what I want to do with this rotation is I now want to set the rotation, set the actor rotation to be that new Lookat rotation. Now this is going to not work exactly like we want, but it should show you how this stuff goes. So let's compile, save all, and take a look at where we are. Okay, so we have a couple problems. It is kind of working. We can run, but notice how our rotations are all messed up. And it's because what is happening is the actor location is the center of the capsule, which is slightly off the ground. The mouse location is being projected down onto the ground, generally speaking. And so what happens is that vector that goes from our character down to the ground has a vertical piece to it, an up and a down. We don't want that. You can see we're totally messing with our characters up and down. So we need to make some changes to fix that. So one of the things we can do is we can go ahead and take this and convert this to just the 2D portion of it, just the X and the Y, not the Z. So let's go ahead and multiply this. And what we're going to do is we are going to multiply this by, let's split this pin struggle. Let's go 1, 1, 0. So that's basically going to zero out the Z aspect of it. And then actually we want this, actually let's keep that one. It's this one, the actor location, that I want to change. Let's split this pen struct. So let's break this, the target, let's split this. And what we're going to do is we're going to take this and we're going to split that. We want the X, we want the Y. We do not want the Z. The Z that we want is we want the same Z as our cached mouse, because we want our mouse and our character to be on the same plane so that we get a flat Lookat. So let's split this, or let's break this. So we'll break this, and I want the Z value for this. Okay? That way they're all on the same plane. Let's see if that fixes our problem. Okay, so if we play, so you'll notice now our character turns to face wherever our mouse cursor is. Now we have a little bit of a problem, and that problem is our character is actually, it's all backwards right now. So we need to flip this, because we either connected this in our target, our start, yeah, we actually connected these in backwards. Notice our cache destination is the start point. That's not the start point. The start point should be our character. So let's break this up again and reconnect it. I can break this just by alt clicking. I am going to, let's just reconnect everything and redo this. All right, so our start, let's split this pin struct. Our start is going to be the X and the Y of our character and the Z of the mouse cursor. And then our end is going to be the XYZ of the mouse cursor. We can just connect these in like so, XYZ. Okay, so exact same thing, just reverse order. That should give us our facing to be what we want it to be. Now you'll notice this is pretty quick. This is great. So we can run around, and our character now runs and faces as they're running. Even if I'm going backwards, etc., they are now facing wherever our cursor happens to be, which is awesome. We are so close to wrapping up the input and control portion of this video. So let's make a couple of quick changes here. It would be nice if we could control how fast that rotation happens. Because what can happen is, if we're here, let me show you what I'm talking about. If we're here and I flip to the other side, it's a pretty quick pop. Now, that's probably fine from a gameplay standpoint. I'm not worried about that. But if you get in here and you start trying to customize animations and everything like that, that's pretty fast. But we can control that. What we can do is we can do something called an RInterpTo. What that means is take the current rotation I have, and that's where I'm rotating to, and rather than just rotating there right away in one tick, what I'm going to do is over a period of time, I'm going to do the best I can to get there as fast as I determine by an interpolation speed. So let's go ahead and do that. What I'm going to do is I'm going to take our actor rotation in this case. This is going to change this a little bit. So I'm going to take our actor rotation. Okay, and I am going to take that, and then I'm going to get the output of this, which we have. And so this is where we are, this is where we want to be. So I'm going to RInterpTo. So here is a rotator RInterpTo. This is where I am, this is my current, this is my destination, this is the target. All right, this is going to be our final rotation. Now, what we need to do is we need to connect a couple of other things in here. So one thing that we could do in this particular case, we could connect in our delta. This is basically, this is how fast time is ticking, and then our interp speed. Let's set an interp speed of 1, for example, and let's just see if that even works. Okay, so we have an interp speed of 1. Now I moved my mouse, look at how fast the character's turning. It's doing its best to get there, but it's very slow. So even though I'm getting to the other side, the mouse is flipping, this is entirely too slow for gameplay. Like, that's not gonna work. But I wanted to do that as an extreme so that you could see. If I set my interp speed to 10, for example, what's going to happen is it is going to calculate that change much faster. But you can see it's not insane now. It's not that quick snap that we had before, okay? So that way you can control how quickly your character is going to turn based on the interp speed. If we crank this up to 100, let's go 100. Let's go ludicrous speed. Okay, so now at 100, it's almost like there was no interpolation. All right, so this is a great thing that we can use to control the visual aspects. Now, where is this going to come into play? Eventually, and we're not going to cover this in this tutorial, but as you move your mouse around, rather than your character sliding in a circle like this, you might want to do some cool animation stuff like turn in place, or you may want to, turn in place is probably the biggest one, but that's going to control how quickly your character can turn around and turn in place. And we're actually going to do a separate tutorial on turn in place. I kind of like the feel of, let's try 50, I liked 10. I thought 10 felt good. So we're going to keep this at 10. Let's see if there's a way we can clean this up a little bit. This is just XYZ. We can just disconnect these. I'm going to do this and recombine this pen. And the reason I'm doing this is because we'll upload this for the Patreon members, so you all can see that in a much cleaner manner. Actor rotation. Once again, we want to, and for all of you that are new, it's really important. We want to keep our blueprints clean, so that the next person that comes along and has to work with them can actually read them. So let's just take this, drop it over here. That's a little more reasonable, okay? Awesome. So you think we're done with our base movement, but we aren't quite done, because we do need to test it on our gamepad. It's a twin stick shooter, right? So let's see what happens with our gamepad if we try to use our gamepad. So walking works, that's cool, okay? Now let's take a look. It doesn't seem like we can use our right thumbstick. That's because we have not connected it. So let's go ahead and add in the connections for our right thumbstick. Okay, so in order to do that, what we need to do is we need to set up a new mapping context. And the mapping context that we want to set up is going to be, in this case, this is going to be our, what we need to do is We basically want to set up a mouse facing context or character facing context, but in order to do that, we do need an input action. So let me go here, and I'm going to add a new input action. And the reason I'm doing this, I'm going to call this input action mouse face. The reason is because we're actually going to get into a conflict with our mouse and our thumbstick here in a second. But basically this is the same thing. It should be an axis 2D vector. That's great. That gives me what I need in my context. I can now go ahead and put in my mouse face. This is going to get this one. We are going to use the gamepad thumb right thumbstick 2D axis. Okay, and I think we want to, let's swizzle it again. Just thinking that that's going to be a thing. Let's save that. Let's go to our controller, and what we want to do is, let's go ahead and take this and let's put our input action mouse face. We'll do that. So this, much like before, what we have is we have our triggered event and we have our axis values. So currently, the way that we're setting our character facing is to set the actor rotation based on where our mouse cursor is. However, if we're using the thumbstick, we don't even have the mouse cursor. We don't even have to worry about where it is. So for now, let's just disconnect tick, okay? Ultimately, what we're going to want to do is we are going to want to get our controller and we're going to want to set our rotation. And the rotation that we're going to want to set is going to be the current rotation. It's going to be a lot like this, okay? It's going to be the current rotation plus a value. So let's go ahead and do that. So with our controller, what we're going to do, with our controlled pawn, let's get the actor rotation. We'll get the actor rotation. And we can go ahead and find the Lookat. In this case, find the Lookat again. We'll use the same thing. And the start position is going to be our current character location. Get the actor location. That's going to be our start. And I'm going to use vector math. Now we probably don't have to do this. Can we get a forward vector? Let's do this. Let's make a vector. Actually, hold on. Let's make a vector. Make a vector. And from that vector, let's get a rotation. Rotator from. Make rotator from. Let's try X. Okay. And then let's split these values. I'm going to split this pin struct. And let's connect in X and Y. Let's see what we get here. If we set this and this is triggered and we press play, what do we get? Okay, so if I press forward, it's backwards, backwards, right, left, forward is back, and back is forward. Okay, so we're flipped right now. So we probably didn't need to swizzle that, is what I'm going with. So let's take that and let's remove this as our swizzle, and let's try that again. So we're facing forward. Oh, we do need to rotate it. Okay, so basically our actor rotation is off by 90 degrees. What I mean by that is when I press up, up is to the left. If I press left, left is down, down is right, right and down. So we're off by 90 degrees. So what I want to do is I want to take the result of this and I'm going to combine the rotator. I'm going to combine two rotators and I'm going to add, I believe it's 90 degrees here. So let's go ahead and do that. Compile and save. Play now, and let's test. Forward is forward, backwards, backwards, left, right. Okay, cool. So let's see what this looks like when we play. So we're moving around, and I'm using my right thumbstick to move around, which is cool. So that is totally working. Twin stick shooter, done. Not really. But what that means is, what we want to do is we do want to do some of our nice interpolation. So to do that, let's go ahead and bring back, we can get rid of this. We don't need this. We do need that. We'll bring that back in a second. Okay, so this is where we want to face. This is going to be where we are facing, get the actor rotation. So this is where we are. and we are going to redo this exact same thing. We're going to rotator interp2 is basically what this is. So this is where we are. This is where we want to go to, and that's going to be our final. And we do need to do something tricky here because we don't have delta here. We're not in tick. This is happening in our input, but what if we're not doing input? Nothing happens. So let's go ahead, and this time what we're going to do is we are going to get something a little bit different. In addition to the delta, we can also, within a tick, we can also get the world delta. And I can connect this in to here. I'm going to set my interp speed to 1 just to test to make sure this is even working and see what happens. Okay, so we can move, and when I right, left, up, down. Oh, it's totally working. It's just slow. So let's bring back that same interpolation speed. Not 110. Let's go 10. Compile and save that, and let's play that and see how our twin stick shooter feels. Oh, gotta click. All right. So as we move around, that's cool. Now, do we also have the same issue? We have a little bit of the same issue. We have a dead zone issue. I think we need to put in our dead zone on this so that it doesn't happen. Because right now what happens is when I let go of the thumbstick, it goes to face back where it was. So let's see if we can put a dead zone on our modifiers. See if that fixes that which way the character's facing issue. So we're moving, facing up, right, let go, doesn't move. Perfect. When I let go now, it stays that way. So now we have 2 versions, and now for real, we're done with our twin stick shooter. Nope, just kidding, we're not done. We have a problem. We have a little bit of a conflict, okay? And the conflict that we have is when our character is running around with the gamepad, watch what happens if I re-enable the mouse. So here we go back down to our top-down controller. If I re-enable the mouse, what's going to happen is every tick, it's going to be looking at the mouse position. But at the same time, it's also trying to do the mouse facing input action from the gamepad. So let's see what happens when we try to play now. If we move our mouse, it's working. We can move using WASD, etc. But I'm going to leave my mouse in this top right corner. I'm going to pick up the gamepad. Now, the moving around works, but if I try to left face, look what happens when I let go. What happens when I let go is it turns to face wherever my mouse cursor is. So this, I can't even face down in the bottom left because the tick from the character is overriding. So here's what we're going to do. When this mouse face is active, we're going to disable the tick. How are we going to do that? We're going to create a new Boolean. And what we're going to call is, let's create a new Boolean. So I'm going to add a variable over here on the right. This is going to be is gamepad active. And actually, I'm not even going to put is, be gamepad active. So Boolean gamepad is active. And then what I'm going to do in here is when we get input from our gamepad, I'm going to go ahead and I'm going to set gamepad to active. That's true. Okay, and then up here, what I'm going to do is I'm going to slide all this over a little bit. And then in here, I'm going to get gamepad as active. And if this is active, I'm not going to do all this. So if the gamepad is not active, this is called a not Boolean. I know this is a little bit backwards. So gamepad is active, not active, then I'm allowed to tick. So let's put in a branch here. So we could do, let me just clarify this for your own learnings. Okay, if the gamepad is active, what we want to do is if that's false, in other words, the gamepad is not active, we can connect in and run. However, it's just general good blueprint practice to prefer true as opposed to false. So either name your variables differently, in other words, gamepad is not active, or what we can do is we can flip the gamepad active and use the not. So is the gamepad not active? If that is true, we can go in here. So now what we've done is we've set it up so that when gamepad is not active, we can do this. So here we go. We're using our mouse, we're running around, that's great. Now, when we activate our gamepad now, we're running around. The minute I press this thumbstick, now my gamepad is active. Tick no longer works. You'll notice that when I let go, the character does not turn to face the mouse. That's because of that Boolean variable that we added in there that lets us do this. Now, if we go back to our mouse, it no longer works. Why not? Well, it doesn't work because we need one more step in here. If we are not triggering this, in other words, when it gets canceled, when it's completed, etc., we need to set our gamepad back to false. So let's go ahead and move all of this stuff over. Let's take this and let's set our gamepad. Let's just copy this and paste it. And what we're going to do is on canceled or on complete, we're going to set gamepad active to false. So let's go compile and save that. Press play. Okay, so first test, mouse and keyboard. So WASD is great, follows the mouse, that looks good. Okay, now let's switch to the gamepad. So if we left mouse, now we've triggered our gamepad active state now at this point. So we're now able to run around and move and do what we want to do. And when we let go, notice it already faces the mouse cursor. I already know this is going to work. So now our mouse cursor is active again. So we have successfully set up our gamepad and mouse keyboard versions for the input for our twin stick shooter. So in all seriousness, that's awesome. We actually do now at this point, this is not another false ending. We actually do have all the setup done for our keyboard and mouse, our inputs, our character facing. We learned a ton about the enhanced input, etc. And now what we need to do is what we're going to do is we're going to make this look a little bit better, because right now when we run around, the character's always running forward. Even when we're running backwards or left or right, the character's running forward. So in the next section, what we're going to do is we are going to get a bunch of cool animations in here so our character will run based on which direction they're facing. Let's do it. All right, in order to dig into the animation BP or the animation aspect of our character, what we need to do is we need to go on a little bit of a tour of how animation works in Unreal. So we have our top-down character. Our character, as we had mentioned before, has a skeletal mesh on it. This is the thing that the animation plays on in this case. The way this is controlled, over here on the right, when we pick our skeletal mesh, you'll see this section for animation. And the way the animation is determined in this case, it says use animation blueprint. And the animation blueprint that it's using is this ABP Manny. If we go ahead and find that asset and we open it, this is basically everything that happens in order to bring the final pose to our character on screen. So let's talk about two main parts of this. We have the event graph, and then we have what's called the anim graph. Now, if you want to go real deep dive, we have videos on that, on the animation blueprints. You can check those out. But the one thing that I want to point out, if you're new, is this event graph. This is where we kind of set up all the logic and the variables and get things prepped for the animation graph. The one that I want to point out here right now is when we come in here on our update of animation, we come in here, we get our movement component, we get our velocity, and we go ahead and use that to set the ground speed. Now, in our anim graph has a couple of different pieces to it. We have our states, our locomotion, and our final output pose. Inside the locomotion state machine, if you look inside of it, you have an idle and a walk run. The walk run is where that ground speed gets used. And what it's being used for is it's being used to drive a blend space, which is a special type of animation sequence. It's actually a blend space. And the way a blend space works is you can combine different animation sequences to create a final output. So let's take a look at this blend space. Reason being is we are going to be making one. So if we open this up, you'll notice that the character is walking in place. That's because currently you'll notice that this axis is set to speed. This speed axis is exactly the same speed that shows up here that the ground speed is driving. If we go back and I control drag to increase the speed, our character starts to walk, and then depending on how fast the speed is, the character will start to run. This is what we're making. we are going to make a blend space that allows our character to run forward, backwards, left, and right. And we're going to connect it in so that all our animations look way cooler in Unreal. So to do this, we are not going to animate from scratch, left and right, and forward and back. That's a whole other discipline. So we do have videos on animation and things like that, but what we're going to do is we are going to borrow assets from the library project. The library project is available for you in the marketplace, and we're not going to go into it, but the quick thing you need to know is under Hero, Abilities, Mannequin, Animations, Locomotion, Unarmed, we are going to take a look at the jogs. Okay, we have a unarmed jog. These are the MFs, so let's get the MMs. We want the masculine ones. Okay, so we have MM unarmed jog backwards. We have MM unarmed jog forwards. We don't need because we already have a forwards. We have a left and we have a right. Now what we're going to do with these is we are going to migrate these to our current project. So let's right click and choose not create, asset actions. Where is it? Asset actions, migrate. Now, this is going to get everything under the sun. We don't need everything under the sun. We only want the animation. So I'm going to uncheck everything else because I don't want to junk up our project with a bunch of stuff that is not going to be used for now and potentially confusing, especially for when I give these project files out to Patreon members. Okay, so here we go. The only thing we're taking now is the forward or the backward, left, and right jogs. All right, we just go ahead and click on OK. And we need to pick our twin stick mini game content folder. We'll just go ahead and select that folder. It is going to do the migration. I am going to go ahead and close this down. Reason being is I've already done one blue screen to death, so don't want to do another one. Now when we do that, if we go back to our project folders, you'll notice we have a heroes folder now with mannequin, animations, locomotion, unarmed in it. If we open these up and take a look at them, you'll notice we have a problem. If I double click on it, oh whoops, it can't find the skeleton. The reason it can't find the skeleton is we didn't bring it over. So we just need to tell it where the skeleton is, and we know that the skeleton in this project is the same as the one that was used in Lyra, which is great. So let's say yes, and I'm just going to pick our SK mannequin skeleton. And I need to do this for each of those. But when I do that, you'll notice that it opens up this character, and as a result of that, let's see here. Should be able to delete these because we don't really need them. These are all foot placement stuff and everything like that, but whatever. We digress a little bit. Let's go ahead and save that. And so that's our jog right, I believe. Let's do our jog left. Same thing. We're going to get the skeleton warning. We'll choose yes, and we'll choose the SK mannequin. It's going to do that. That looks good. And then let's do our final one, which is backwards. Can't find it. Yes. SK mannequin. Okay. Now this one, when it opens up, you'll notice, I want you to notice that there's a difference. The previous ones were in place. This one is actually moving through space. We don't actually want that. We want this to be in place. So I am going to disable root motion down here on the left to basically lock this animation in place. All right. And that wraps up migrating our assets almost. I want to take all three of these and I am going to go ahead and move them into the Manny folder. So let's move them here. I'll clean up redirectors and then I'm just going to delete this heroes folder. Okay, one last thing I want to do with these animations is I want to change the default display asset to be Manny. And so we'll click apply for that. I'm going to do that for each of these three because I don't want to have to load Quinn each time. Manny, apply to asset, that's the left, and then backward, just make sure it's Manny, apply that to the asset. We should be good. Okay, so let's just save these three. And now we have the animations that we need to create our blend space. How do we create a blend space? Well, what we do is we'll go to our meshes folder. I'm going to right click on Manny. I'm going to choose create and I'm going to choose a blend space. Now, the blend space that was there previously was one dimensional and only had one axis. We need two because we have front to back, left to right. So let's just create a blend space. This is going to be called BS for Blendspace Move. And let's take a look at how this works. All right, so the way the blend space works is down here we have our cardinal directions, our left and right, up and down. Right now you'll notice our axes have no labels. They're set to none. Over here on our left, if we look, we have a horizontal axis. Let's label this. Let's call this left, right. And let's take our vertical axis and call this forward, back. And we need to make a couple changes. Look at the minimum and maximum values on our axes. 0 to 100. We kind of need to go backwards just as much as we go forward. So I'm going to change these to be -100 to 100 in both cases. All right, now that our axes are set up, all we do is drag and drop stuff onto it. So let's drag our forward. We want let's get this forward. So run forward. I'm going to drag this up here. So our character starts running right away because there's only one item in our tree right now. And then we're going to go ahead and where's our backwards? Here's our jog backward. I'm going to drop this down here. And now if we control drag, this is forward running and this is backwards running. You can see the difference as we do this. So now all we need is left and right, right and left. So let's see if we get these correct. So left is going to go over here and right is going to go over here. All right, so now if we control drag, you can see we have our right and our left. I think we may have these flopped. We'll have to fix that in a second. We have our up and down, which is great. And we do need one more thing. In the middle, when our character is not moving, we don't want them running. We don't want them left and right. We want anything. Let's just go ahead and drop in an idle. Okay, so here's what we need to do. Let's go ahead and make sure all of these are properly, perfectly aligned. Over here on the left-hand side, we have our blend samples. Our run forward should be 0, 100. So I'm just going to type these in so I get perfect numbers. Our backward should be 0, -100. Our left should be 100, 0. And our right should be -100, 0. And our idle should be 0, 0, 0, 0. Okay, so now we're set up where everything is left, right, right, left, etc. That's all cool. Backwards, forwards, perfect. Let's save that and close it down. Or I'm not going to close it because we may need to flop left and right. We'll see here in a second. All right, so now that we have that, all we need to do is we need to connect it up. Now, we know we don't need ground speed. We have our walk run. We're going to replace this over here on our right. We're going to change this blend space to be our move blend space. When we do that, we get only one of our axes. That's because Unreal doesn't know to update this. If we right click and choose refresh nodes, now we have our left and right and forward and back. So we have the directions, but we have no way to drive them because we only have this ground speed. So what we need to do is we need to create a couple, or at least a variable that will allow us to drive this move. So let's go back to our event graph because that's where we do that. Now, just like we've done here, we got the velocity. What we're going to do is we're going to take the velocity. All right, and what I want to do is I want to normalize this. The reason I want to do that is because I want to be able to make changes to it. It is possible that as our character is going up a ramp or down a ramp, that our velocity has verticality to it. But remember, to control our animations, because we're doing a twin stick shooter, we don't want any verticality to that. So what I'm going to do is I'm going to take and I'm going to multiply this. And once again, we have tons of videos on vectors, or we have at least one video on vectors that you all can watch if you want to learn more about vectors. But basically what this does is by multiplying this by 1 in X, 1 in Y, and 0 in Z, it removes the vertical aspect of our character's movement, and we can use this to create a new variable. And that new variable we're going to call input 2D. And I'm going to set this to be a vector 2D. And what we'll do is we are going to set that. Now, reason being, or the reason we're doing this, is we need to be able to drive our character's motion. So if we take this output and we just connect it to our input, this is going to connect in and set our 2D input 2D vector that we can use now all throughout our animation graph in our blueprint. So let's compile and save. And in our walk run, what we want to do is let's take our input 2D, we'll get it, and we'll just split it. Let me split this spin struct by right clicking left and right. Go ahead and compile and save. Now, theoretically, if we've done this right, when we press play, we should see our character run forward and backwards, but we do not. Why? So if you recall in our blend space, remember our blend space goes 0 to 100. We took the velocity, we normalized it to direction, so it only goes 0 to 1. So technically, theoretically, it is working, but what is happening is we're only going 0 to 1. The reason I chose 0 to 100 is there is a world where maybe we want to add in the idea of a walk. And so maybe between 0 and 25, it's a walk, and we could add those into this blend space. But for now, we're not going to worry about it for the purpose of this demo. I just wanted to talk about that. So what I'm going to do over here is I'm going to take this value, the directionality of it, and I'm just going to multiply it. I'm going to multiply it by 100. Okay, and I'm going to do the same thing here. I'm going to multiply it by 100. Okay, and then we're going to go ahead and connect this in. Now, when we move forward, we should get a run. We do. However, we're getting a left to right run. If we go left, we're getting a forward, and if we go right, no, if we go left, we're getting a backwards. If we go right, we're getting a forward. So what's happening is our input ordinals don't match our character facing. So what we need to do is we need to come back and make a quick little change to our final input here. So here's what I'm going to do. I'm going to take this and I am going to rotate this. I'm going to rotate this vector by 90 degrees. I believe 90 degrees. So when I do this, now what should happen when we play is if we run forward, we have forward, that's perfect. If you go backwards, that is definitely backwards. If we go left, that is our left run. If we go right, that is our right run. Perfect. We're done, right? Nope, not done. Reason we're not done is because even though this works when we're facing forward, look what happens when we face to the right. If I face to the right and I go up, W key, right? I'm running forward. And if I go down, I'm running backwards. So what's happening is our character's run, the input 2D that we're creating, is not taking into account our character's rotation. So we need to take into account the difference between our character rotation and the controller in order to properly get this so that we're always running forward based on which way we're going, based on the mouse cursor position or our thumbsticks. So to do that, in our Mani BP, we are going to go back to our event graph. And what we want to do here is we should have a reference to our character, and we do. Okay, so with that, let's get our controller rotation. And let's get our actor rotation. These are the two things that we said we wanted to use to determine whether or not we were, how to properly account for the difference between. Now I just said the word difference. Another word for that is delta. So let's get the delta between these two. Now that we have the delta between these two, if we take that and we connect it back in here, it will work in the sense that it will start to account for the difference between the two. However, it will also still be facing the wrong way. So we do still need this 90-degree offset. So let's go ahead and add that in by putting a combine rotators in here, which just means let's just add. So we're going to add our 90 degrees back in here, and then we're going to connect the output result of that into our rotating vectors. Let's compile and save that, and let's go ahead and push play and test it. So first base case, run forward, great, back, great, left looks good, right looks good. Now, if we rotate 90 degrees and I push the right thumbstick or D key, do we run forward? We do. And if we go backward, we run backward. That's fantastic. If I go up, I'm running left now, and if I go down, I'm running right. So now my character run makes more sense based on which way they're facing. And it also works with the thumb pad. Okay. Now, one thing I don't like about the thumb pad thing is when I let go, the character instantly faces the mouse. That's because when we put that cancel out, I would probably remove that. If you're going to use thumb pad, just disable it for the whole time. But overall, now, whichever way we're facing, the character is running properly based on what it is. So we were able to take really quickly just a few animation assets, feed those into our animation blueprint, take that information, and now our character moves so much better in the level. It looks a lot, it just visually is not nearly as distracting. And we learned a ton about how the character facing, the controller facing, how the Anim BP variables work, how to use those to drive a blend space. So with all that, everything's looking great. What's next? I'm thinking we need some enemies before we get into, I mean, we can't get to a win condition if we don't have enemies to destroy. So let's go ahead and set up some enemies. All right, in order to get our new enemy started, what we need is we need a blueprint. So Unreal knows how to display it and what to do with it. So what we're going to do is we're going to right click here and we're going to choose new blueprint class. Now, the first three are probably the most applicable. We have an actor, a pawn, which is just an actor that can be possessed, that could be an enemy. But then if we look one more, we have a character, which is a pawn that also includes the ability to walk around. And for this enemy, we want them to be able to walk around because we're going to be using the same character meshes and animations and everything that our player is using for the purpose of this demo. So let's just go ahead and call this blueprint enemy base. And what we are going to do with our enemy base is we are going to start to set up our visuals. Now, as you'll notice, when we load this up, it is just a capsule. There's no visual set, just like we described very early on. In order to set the visuals, what we're going to do is we're going to choose our mesh component over here on the left, and then over on the right, we're going to set our skeletal mesh to be Manny. Now, one of the things I want you to notice is when Manny comes in, Manny is floating off the ground, because Manny is actually, based on where the capsule is, halfway up the capsule. If we were to drop our enemy into our scene and take a look at it, you'll notice that the character is floating just basically way above the ground. The reason for this is because, once again, the capsule is the one that's doing all the work. The visual is a magic trick to align and to give the player the illusion that the enemies are actually moving with it. So what we need to do is let's move all this stuff down. We're going to take our mesh. How far do we move it down? Well, we could just eyeball it, move it down until it looks like it's good, or we can take a look at our capsule component and we can see that it has a half height of 88, which is how tall it is, and we can just type in a negative 88 here for our Z value, and now our character's feet will line up with the ground perfectly, which is great. Let's compile and save that. Now the next thing that we want to do is we want to make it so our character can move to kind of bring that illusion to life. So we're just going to reuse our Manny blueprint for now. I'm going to show you a couple problems with it here in a minute. And when we take this now and we look at our character in scene, we now have an enemy. We actually have an enemy in our scene, which is great. However, if we had more than one player or for visual clarity, it would be nice to know and very quickly be able to identify where the enemies are versus where I am. Shouldn't be too bad because we have a locked camera right now, but in general, it would probably be great to be able to differentiate these two. So to do that, we are going to talk a little bit about the materials. If we take a look at our mesh over here on the right, just below it, you'll see we have materials. We have a material instance for Manny 02 and one for Manny 01. I'm going to click this to browse to the asset, and I want to show you a couple things. A material instance is an instance copy of a parent material. Let's take a look at Manny 01. Okay, now when we look at Manny 01, what we have here is we have a bunch of options that we can change. We can change the textures and the tints and all kinds of different things. This is actually all given to us as options as a result of the parent material. If we open the parent material down here on the right, we can actually just browse to that and open that up. You'll notice a distinct difference between a parent material, an actual material, and a material instance. This has the entire graph of everything that's going on. This is all of our colors, this is all of our tinting, everything that goes into this material and gives us the options that we have when we look at this material instance. This is done because it's an efficiency thing. It's a whole lot easier to have one material with slight variations than it is to have every single material in your game being the same thing. So this is a material graph. There's a lot that goes into it. There's separate topics on how that works. But for the purpose of us, what we are going to do is we're going to reuse these Mani material instances, and we're going to make them red. So let's take a look at these instances. I'm going to create a new folder over here called Enemy. And then I'm going to copy the Mani materials into the enemy folder. And when I do that, I'm just going to choose copy here. Now, if we look at our enemy folder, I'm going to rename these so it's clear. These are enemy 01 now and enemy 02. And then what I want to do is I want to change the colors. So let's go ahead and let's just change the tint of this. So we're going to tint this to be red, for example. And let's save that. And then let's go to our second material and we'll do the same thing. We will change the tint. So in order to change the tint, we need to check the box, turn this on. I'm going to use the same values, 10.25. You can use whatever colors you want. Let's go ahead and click save. And then what we need to do is we need to set our enemy to use those materials. Now, we don't want to change the base skeletal mesh, but fortunately, because of the way all of the inheritance and everything works is we can just change the material for our enemy base. So over here on the right, what I'm going to do is I'm going to replace Mani 02 with enemy 02, and I'm going to replace Mani 01 with enemy 01. And now you'll notice that we have a nice red enemy to work with. And when we look at this in the level, it is a whole lot easier to see who I am versus who the enemies are, which is great. Now, what would be awesome is if we could get our enemy to move relatively quickly and chase us. So let's see if we can't set that up. And the way we're going to do that is in our event graph, for the enemy, what I want to do is I want to just simply tell it to chase us when it spawns. Okay, we're not into AI or anything like that yet. Simple just for testing. Let's on begin play. Let's do a simple move to. And we're going to do a simple move to actor. The actor we're going to move to is we want to chase the player. So let's get the player pawn. We're going to get the player pawn. And that is going to be the goal. That is the goal of this move to. And then the controller that is going to be doing the moving is the enemy's controller. So right now we're in the enemy blueprint. Let's get the controller. And what this is going to do is it's going to get the controller for self, because my self from the frame of reference of the enemy is the enemy. And there we go. And now we have it. Now, if we save this, I'm going to move my enemy a little further away for now. And then when we play, let's just see if they start running towards us. They do. Now, the interesting thing is, as they're running towards us, notice there is no animation. Why aren't they animating? The reason for this is in our animation blueprint. The easiest way to find it is in our enemies. If we click our mesh and we go to find our animation blueprint, you take a look at this. What we have here is everything should be working logically in the sense that this is a character. We know it's a character when we initialize our animation, so we're setting our character. That should be valid. This is our character movement. That's also valid. But look at what happens down here. We set our ground speed. That's great. But down here, we set this variable should move. And should move is being set based on the movement component's current acceleration and whether the ground speed is greater than 3. The current acceleration is determined by the player pressing the thumbstick or pressing WASD. If we don't have acceleration, if we go into our locomotion, let's see here, let me show you where we are. In our anim graph, if we go into locomotion, we go into this, you can see this is a state machine. This is an animation state machine. The way this works is we come in here, we play idle. And then these conduits have rules. The rules that allow you to transition to walk to run or back to idle. And in this case, the rule that is being used to transition is should we move. So if should we move is false, it will never get to walk run. So what we want to do is go back to our event graph, and we need to find a way so that if this is an enemy, we would set should move. Now, there's a couple of different ways to do this. We could create a whole new Anim blueprint for enemies. We could, or which ultimately you will probably end up doing depending on how your enemy is set up. But in this case, just from a simplicity standpoint, here's what I want to do. I want to take our character and I want to do one more cast here. What I want to do is I'm going to take our character, let's see here, our references, and I'm going to cast that to an enemy. And if that is true, I'm going to create a new Boolean variable. Okay, and that Boolean variable is going to be let's call it enemy. Is enemy. Okay, and what we're going to do with this is we are going to set this is enemy. I think before I called it AI controlled, but I've had a couple of blue screens, so that's why that was there before. So if that's true, we're going to set is enemy. If the character is an enemy, then we're going to set it as is enemy. Then all we're going to do down here is we are going to go ahead and if our ground speed is greater than 3 and we have acceleration, and let's put an or in here, or our character is an enemy, then we're going to set should move to true. So ground speed greater than 0, that's going to be true if it's moving, and current acceleration might be false, but if it's an enemy, that's going to result as false or true, which will be true, and so we should get movement. So let's go ahead and compile and save that, and let's go ahead and play. Look at that. Our character, our enemy is now running, which is perfect. And then when they get to us, they stop. Now, the interesting thing about our enemy is they are not facing their movement, so we may need to turn our character. I think our character is 90 degrees off. Let's take a look at our mesh in the viewport and see which way it's facing. Okay, take a look at this. Our capsule, look at which way our capsule is facing. You can see it by this blue arrow. Look at which way our enemy is facing. Okay, our enemy needs to be rotated 90 degrees. So let's go ahead and rotate this 90 or minus 90 actually. Okay, so let's try that one more time. Press play. There we go. Our enemy is now turning to face us, which is cool. So our enemy is now chasing us. Now, there are a couple of things like why do they stop when they get to us? That's just part of the condition of this simple move to. When they reach their destination, the character is going to stop. Now we could try a different move to here. We could try an AI move to. So let's do this. Let's do AI move to see if we get a different response from that. Okay, so the pawn is going to be ourself in this case. And our target actor is going to be the player. And we are going to try an AI move too. This may still stop when it gets there because it's not actually renewing itself. So let's just see if it does the same thing. Nope. Yeah, it did stop. It stops when it reaches the acceptance radius. So what we're going to need to do is we're going to need to put in logic where if it reaches us, it will keep trying to reach us. But overall, we have successfully dropped in our enemy and made it so that the enemy will chase us around. We set up the visuals and all those kinds of things. Now, what we need to do is we need to set up, we have a couple options now. What we could do is we could set up the ability for the enemy to do damage to the player, which I think is a good idea. And then after we do that, we're going to give the ability for the player to fight back. So let's go ahead and set up some damage using some components. Here we go. All right, so in order to do damage, we need two things. We need health and a way to do damage. So let's talk about health first. Generally speaking, health is a floating point number. it's 100.00, 93.2, whatever that health happens to be. And what we could do is we could simply take our hero character, we could add a variable like this, call it health, change it to be a float, and then what we would do is any time that we wanted to do damage, we would just reduce this health value. However, that is not very sustainable. We can't reuse it. So what I mean by that is then if I want to put health on the enemy, what I have to do is I have to open the enemy blueprint. I have to add a variable called health, and anything I make change wise to the hero, I then have to do to the enemy. That's not awesome. So even though this is a beginner tutorial, I still want to teach you all to think modularly and reusably for the future. So what we're actually going to do is we're actually going to create our own component. And this does a couple of things. But first, let's start with, I'm going to delete that health variable. Let's just start creating our own component. So over here in our in our content browser, I'm just going to right click and choose blueprint class. And I want an actor component. We're going to call this component health. Now, there's a couple interesting things about our health component. It's a little bit more reduced version of a regular blueprint. You'll notice there's no viewport or anything like that. But here's the cool thing. We can take this component and we can add it to any character we want, and the character will get all the abilities that are within that component. So what I mean by that is, let's take this health component and add a couple variables, because we need a couple variables to work with. So we're going to add our health. This is going to be a float. And then I'm also going to add max health, because what I want to know for a character is I need to know their maximum health so I can properly display damage and things like that. So we have health and we have max health. And then what we want to do with this component is we want to add it to our hero. So just like we've been adding components so far, actually let me compile and save this real quick. All we have to do is click add. If we type in health, we can choose our health component. Now, the cool thing is with this health component, you'll notice that over here on the right, I have the default values for health and max health. I got those just by dropping this component on the character. So everything we do to the hero now, we are going to do to the enemy by adding the health component. So now our enemy has a health component, and what that means is they also have a health and a max health, which is awesome. So we're going to get the enemy health almost for free as we do this. So here we go. With our health component, now that we have it, what do we need to be able to do? Well, let's do a couple things here. First off, on begin play for the health component, the first thing I want it to do is I want to set my health. And what I want to set my health to is I want to set it to my max health. Reason being is just as an initialization step, if a character's max health is 100, generally speaking, we want to start at the max health. So let's set our default value for max health to be 100. We'll compile that and save it. Now, what we need to be able to do is we need to be able to change the health, affect it. So here's what I'm going to do. I'm going to add a new custom event, and this custom event is going to be called event affect health. And in order to affect the health, we need to know how much we're going to affect it by. So what we can do with events is we can add something called an input. So over here on the right, I'm going to click on input, and I'm going to call this amount. Now this is also a float. We want to set this. And if the idea of variables is new to you, etc., it may be worthwhile to go back and check out some of the fundamentals videos. So this is an amount. And now what that means is when we start with, or when we call affect health, what we can do is we can set our health. Now, here's the interesting thing about affect health. What we want to do is we want to set our health equal to the current health plus the amount. Now, why do we want to use plus the amount? We want to use plus the amount because the amount that we're affecting the health by could be positive or it could be negative, which is cool because this event health can be used to also heal characters or anything in the scene that has a health component, for example. So what we're going to do is we're going to come into affect health, we're going to add the amount to the current health, and then we are going to set that as our new value. So if I started at 100 and my amount was -50, my new health amount would be 50. Okay, now let's go ahead and do another thing. Once we have our health, let's go ahead and see if it's less than or equal to 0. And if it is, what I want to do is I want to destroy our character. Now, ultimately, this is not what we're going to do, but I want to show you what happens. So let's get our owner. And the owner is the owner of this component. Who is this component on? So we're going to get our owner and we're just going to destroy our actor. Now what this is going to do is once our hero's health goes down below or equal to 0, it will destroy it. And actually that goes the same for the enemy. But before any of this works, what we need to do is we need a way to do damage. This gets into a little bit more of the other component we're going to be adding to help us do all of this. We are going to add a box collision here. This box collision is going to be, if we look at our viewport, it's going to be out in front of our character. Okay? And the idea here is whenever this collides with the hero, it's going to apply the damage. It's going to do damage. All right, so let's go to our event graph. And what we want to do is we want to add an event. So on overlap. So whenever anything overlaps this box, Okay, so with the box selected, if I right click, I can choose add an event for the box, and I want this to be collision. So on component begin overlap. All right, now what I want to do is what I could do here is I could get the overlapped actor. I could cast this to a top-down character. And if it's true, then what I could do is I could get that component, get the health component. And with that, I could affect the health. And I could set it to, let's just say -200. Just so we can see what happens when our character gets damaged. This is ultimately not how we're going to do this, and I'm going to show you why here in a second, but theoretically when this box overlaps our top-down character, it's going to affect the health, which is then going to cause our top-down character to look at its component, and then our health component is going to set the health, it's going to be less than or equal to 0, and then we're going to destroy our actor. So let's just double check that all of our health is right. It is. So let's go ahead and press play. Now if he catches me, I die. Basically it just vaporizes my actor. So you can see here we've popped completely out of our game. That is not the way that we want to destroy our characters. There's basically what we want to do, and we're going to go back to the health stuff here in a second, or I'm sorry, to the collision stuff here in a second. But the whole point of getting the collision working was so I could show you what we're going to do with damage. What I want to do is something different if it's a player or an enemy. So what we need to do is we need the idea of a boolean enemy is enemy. Let's go is enemy. Okay, so, and this is going to be a boolean. All right, and so what we'll do is on begin play, I am going to get the owner and I'm going to cast that to an enemy base. If it succeeds, then I'm going to set this to true, for example. If it doesn't succeed, it will stay false. And either way, I want to continue on. So I want to get the owner and I want to get the controller, not the AI controller. Let's get actually, let's cast this to a character. And then as a character, we're going to get the controller. Get the controller. And then we can take this controller and we can cast that to player controller. Now, I'm on the fence. Maybe we store this. I think we should store this. So what do I mean by store this? Okay, first off, a couple things to go over. What is all this casting stuff? We've talked about it loosely so far, but basically it's just a way for me to say, take whatever the value of this thing is and try to see if it's a character. If it is a character, great, go do this. If it's not, we're just gonna fail out. Okay, then with the controller, what I wanna know, or with the character, I'm going to get the controller, and I wanna know if this controller is a player controller. It could also be an AI controller, for example. If it is a player controller, what I want to do is I want to store this. I'm going to promote this to variable. So this is going to be our player controller variable. And I have a feeling we're going to need this later, so I'm just going to make it now. So if it's not an enemy base, we do still want to go ahead and try to see if it's a player. So make sure we get this around. So that way, if it's not an enemy base, we can check, make sure we check the box as well. There we go. All right, so why did we do all of that? We did all of that so that we are set up down here where what we can do is if it's less than or equal to 0, we want to check to see if it's an enemy. Okay, if it's an enemy, if that's true, then we can just destroy it, because an enemy we don't have to do anything fancy for. Okay, so we'll just destroy it. If that's false, let's get the player controller and see if it is valid. Now, it wouldn't be valid if, so right now if we were to put this component, this health component on the player or the enemy, that covers both. But what if we put it on a spawner or a door or anything else that we want to be able to do damage to? So we need to do one more check here. We're going to check to see if the player controller is valid. If the player controller is valid, that means we need to do a little bit more work with our player. So let's just take this, and there's something like input. No, it's actually disable input. So what we'll do is we'll disable the input. So what should happen this time when we get destroyed is it should come in here and just make it so that it's disabled. Now, actually, the way this takes, let's see what this takes. This takes an actor and a player controller. So actually we need to change this. We're just going to try to use just the player controller for all of this. Let's see if that's what it is. Yep, that did it. So I just plugged the player controller into both of these. So what that does is that makes it so the input is disabled. So now we can no longer move, but maybe we can have a little bit more fun with this, and maybe we can I can show you all how to ragdoll your character. So after we disable our input, let's do this. Let's get the controlled pawn. I know we just deleted that node, but let's get the controlled pawn. And what I'm going to do is I'm going to do something called get component by class. And the class of the component I want is the skeletal mesh component. So what I'm trying to do here is I'm trying to get a reference to the skeletal mesh component so that I can do some cool stuff with it. And the cool stuff I want to do is I want to set collision enabled. And the collision enabled setting I want to use is I want it to do physics and query and physics, because I want it to basically do everything it needs to do. And then what I want to do is I want to set simulate physics on that skeletal mesh. I'm going to set this to true and connect this in. So very quickly, we were able to grab the information we need, and now when we get destroyed, we should ragdoll. There we go, we got it. Okay, so our health component is already doing really cool stuff. Now, let's go back and let's talk about a couple things with our health component. We're going to compile and save. So right now, the way this is working is when our enemy base overlaps with something, it's trying to cast it to check to see if it's a top-down player. This is not the most efficient way to work, because what that means is we are going to have to, as the player, we're going to have to check for the enemy. As an enemy, we're going to have to check for the player. If there's a spawner in here, take any number of things that you could possibly use. We don't want to have to check for all of them. So what would be really cool is if there was a way we could just send a message that's saying, hey, if you understand how to take damage or affect health, do it. And if they don't understand it, it's just like a foreign language, they just ignore it. Well, there is something for that. It's called a blueprint interface. All right, we are going to be using a couple of them, I think, throughout this tutorial. If you want a deeper dive, you can go ahead and watch the videos. There should be a link around here somewhere, but overall, the easiest way to think about it is a blueprint interface is a messaging service, and it works just like I described. The enemy is going to say, hey, the person I just hit, the thing I just hit, do you understand how to affect health? If so, affect health. And in the spawner or enemy or player, whoever is there, they're listening to it. If they know how to listen to that message, then they will affect the health if they know how to. Otherwise, they'll just ignore it and go about their merry way. So here's what we're going to do. We are not going to do this cast. Okay? We are possibly going to... Nope, we're not even going to do this affect health. All right, none of that. What we are going to do is we are going to make a blueprint interface. Okay, so over here, I'm going to right click and I'm going to choose a blueprint class. And the class that I want is, actually no, sometimes it's hard to find here. So let's go blueprint, and there's a blueprint interface one. That's the easiest way to find it. This is going to be a blueprint interface, and this is going to be health. Now, these are weird, okay? If you think about it as a messaging system, you'll start to wrap your head around it. If you don't understand this, it took me a long time to wrap my head around this. So like I said, go watch the video if this is too confusing. Now, it shouldn't be. We should be okay. So all we need to do is tell this messaging, this blueprint interface, what kind of messages it knows or it can deliver. Currently right now, the message that it delivers is called new function. We are going to create a function called affect health. Affect health. What this is this is saying that this messaging system, this blueprint interface, knows how to affect health, and it can send a message. It can receive a message and send a message to affect health. Now, just like our original affect health, we do want an input, and this is going to be the amount, and we want this to be a float. That is it, almost. Our messaging system is built to affect health, but now what we need to do is we need to tell each of our characters to listen for it. All right, so I'm actually going to come back to let's start with our enemy. The way this works is under your class default or class settings, there is a implemented interfaces. Remember, we just created a blueprint interface. If we click on this add option and we type in here health, you'll notice that the blueprint interface health that we just made shows up. Once we do that, look at what happened over here on the left. There is a new function here called affect health or event. And what I can do is I can right click on this and I can implement that. So if somebody were to tell me to affect the health, I could respond to it. Now I can do the same thing the other way. So rather than doing all the casting and everything in here, all I'm going to do is I'm going to take this other actor and I'm going to type affect health. See how it's a message? So what this is going to do is if I overlap another actor, I'm going to affect the health by a negative. Let's keep it at 200 for right now. Okay, we do not need this here right now. Okay, so now that our enemy is sending the message to affect the health, let's go to our hero. We need to do the same thing. In our class settings, we need to implement the interface. We need to tell the hero that it understands this interface, this messaging service for health. And all we want to do is this one, we are going to implement this. So if you notice it popped up over here on the left, I'm going to implement this event. So down here, what I want to do is I want to take my component health, and I do not want to confuse you on this, but we're going to affect the health. So I'm wondering if I should rename this just for this to be... I'm going to rename this real quick. I'm going to go back to our blueprint interface, and I'm going to call this do affect health, because I want you to be able to see the differences. Okay, so when we do that, you'll notice that we need to compile this. Let me delete this, and we're going to right click and implement this event. Okay, so you'll notice that this is the interface call. This is the message call, event do health. Event do affect health. Let's make sure our enemy is doing that. Here we go. This is our do affect health. It updated. Okay. So with that do affect health, what we're going to do is we're going to call affect health from the component. So this event is actually the one that we implemented originally in our component. If we double click, we can go and see this is what it does. This does all of our ragdolling and everything that we had already done. So basically, let me compile and save all this stuff. Basically, our hero is going to get a message. Do you know how to understand how to affect health? Yes, I do. And this is what I'm going to do with it. And that is it. Okay, so let's compile and save this. And as long as we got this all connected properly, we should still do the same thing. There we go. We're affecting our health. That's all done without casting anything, without having to put in, are you a spawner? Are you an actor? Are you a destructible? Or what are you? I don't have to do any of that. I can just say, hey, affect health. So that's awesome. All right, so now that we can affect health, the other thing that we would like to be able to do is we'd like to be able to see how much health we have left. So wouldn't it be cool if we had a health bar? So let's see here. And actually, just before we hop to adding a health bar, let me add one more comment. Our enemy is currently able to do the affecting of the health, to do damage. We have not added that ability to the hero. We are going to do that later when we get into the hero's ability to shoot projectiles and defend itself. So back to what I was saying, we're going to be creating a health bar. So we've got a whole UI lesson inside of our minigame. So let's go over here. We're going to our folder. I'm going to create a new folder here. I'm going to call this UI. And in this UI, what we need is something that Unreal calls a widget. So if we create under the user interface a widget blueprint, I'm going to create a user widget. So the UIs that pop up, generally speaking, are user widgets in Unreal Engine, all right? So we're going to call this widget blueprint health bar. Okay, now when we open this, let's go on a quick little tour. There are two main parts to a health bar. There's the visual part, that's all done in the designer, and then there's the implementation, the functions, the events, the logic. That is all in the graph, the event graph. So for us, what we need is a health bar, visual. So generally speaking, the way these work is you need to put down like a container for everything to sit inside. The container I'm going to use is a canvas panel. So I'm going to take this, I'm going to drag this in here. This is going to be where our health bar lives. And then I also want to create a progress bar. This is actually going to be our health bar. And you can see it's a nice looking progress bar. So I'm going to set the size of this to be 100 by 10. And then what I want to do is I want to set our progress bar size to be 100 by 10 as well. So let me zoom in here, and also let me make everything a little bit bigger. Sometimes when the system crashes, I forget to do that. Okay, so we have our progress bar. Now the way a progress bar works is if I click on this, let me show you, it has style. So what we're going to do is I want to change the background tint, and I'm going to change the background tint to be, let's just go something like that. Maybe a little deeper red. So that's what it'll look like when the progress bar is empty. So I want it red because that's bad. Okay, now when we are filling it, we want it to be, let's make it a nice bright green. However, you don't see any of the green. The reason you don't see green yet is because it has to be filled by a certain percent. So if we change this to 50%, let's compile this. Hold on a second. Fill color and opacity. Oh, I changed my opacity. Okay, so I accidentally typed in a 0 for the alpha. Okay, so back to what I've shown you. You can fill this bar by changing the percent. Well, that's really cool because we also have a max health and a health. So we can use those to figure out a percent. That's awfully convenient. Okay, so anyways, back to what we were doing. We have our health bar. Now what we want to do is when we add our health bar to our character, it would be great to get the health component information at the same time. So what we're going to do is over in our graph, I'm going to add a variable. And once again, variable is just a bucket. It holds information, it holds a value. In this particular case, this is going to be our health component. And what I want the type to be is an actual health component, object reference. So now what I want to do with this is when this gets added, I need to make sure that I can edit these values. So in order to do that in Blueprint, what we do is we set it to instance editable and expose on spawn. Now I'm going to show you where that shows up here in a second. So we now have our, basically I'm just going to delete all these for now. We don't need any of them. We basically have the ability to set our health bar component. However, we need to connect that somehow to our widget, our progress bar widget. So over here, what we can do is we can do something called binding. Now you're not going to be able to see this because it's off screen, but basically we can bind, and we could bind to that to the health component, or we can create our own binding. So what I'm going to do is I'm going to create our own binding. And when we do that, it pops up a get percent binding. Now what I want to do is I want to take my health component. I want to get the current health, and I want to divide this by the max health. Get the health. So here's max health, and we're going to divide this. Divide. Okay. So what this is going to do is, using this health component, it is going to, and we could probably put in an is valid here just in case, but basically it's going to figure out the percentage, and that is going to drive how much green is visible for us. This is awesome. So we have our widget made. Now we need to use it. So first things first, let's start with adding it to the hero character. So back here in our event graph, actually before we even do that, let's go ahead and add it as a component. So we're going to add a widget here. This is going to be empty to start with. We're not going to do much with it. And then in begin play, let's take begin play. We need the begin play back. What I want to do is I want to create a widget. And the class of widget I want to create is a health bar component, or a widget blueprint health bar. And what I want to show you is the minute I set that value, look at what showed up here, health component. So what we want to do is we want to plug in our health component to here. Okay. So that way, when this starts, it actually gets the health component information straight off the bat. Now, this isn't quite done yet. The next thing we need to do is we need to set this widget to be this created widget. So let's just go ahead and set widget. And the cool thing is it'll automatically kind of set that connection up for us. Okay, so now that we have all of that, let's save everything. And let's see what this looks like. I'm not expecting this to look right. So when we press play, why don't we see our health bar? Okay, let's go back and talk about a couple things. This widget, you have options for how it's displayed. You can display it in world space or screen space. So just this one little switch, let's go ahead and switch this to screen space. I want to show you. Now all of a sudden we have a health bar. However, our health bar is way, by the way, it's working. It's pretty cool. The minute we lose all of our health, we get knocked down to 0 and the whole bar goes red. So it's working, which is cool. However, it is actually offset. So let's take a look at what is going on with the offset. If you look at our viewport, what I really want is I want this widget to be right above our character's head. However, the problem is there's a whole bunch of weird offsets that are baked into the UI stuff. So we're going to need to make a couple of changes. So first off, let's go back to our health bar. There is the idea of anchoring something to a canvas panel. Where does it get anchored to? If you look up here, right now I have this in the top left corner. Well, the problem is that left corner gets used as an offset on our character, and so it spins around in weird ways. So what I want to actually do is I want to change this anchor to be in the middle, dead center. All right, and that's going to help us get that widget aligned straight over our character's head without any extra offset. So let's just see how we're doing. So already just that change alone has got the widget just right above our head, which is perfect. Okay, now let's go back and make a couple changes. I'm going to do 50 damage instead of 200. And the reason I'm going to do that is I want you to see that the health bar only goes halfway. It's awesome, right? Okay, so that's great. So now what we can do is we can take damage as the hero or our player character, which is awesome. And we did that simply with the effect health, and we have our health bar widget. Okay, so let's go ahead and do the exact same thing for the enemy. Now, you might be wondering, the same way that we made a modular component for health and a blueprint interface, and we're thinking all, you know, reusability and all those, why didn't we do that with the health bar? The reason is, for the case of the hero, I actually think it's going to be a little distracting to have the health bar above their head. We'll probably want to move that to the heads-up display, the HUD, later. So let's just go ahead though and take all that work we did for the hero and just copy that in here. So here we're going to add a widget. Okay, and that widget is going to be in screen space. And then what we'll do is we'll take our top-down character and we'll just grab all of this and we can just paste it in after our begin play. Okay, and actually I'm going to do this after our simple move to, which is also going to be changing later on when we get back to fixing the whole it stops when it gets to where its destination is. Okay, so now what we should have is we should have a health bar over enemy, we should have a health bar over hero, and the health bar over the enemy is probably going to be in the wrong place. It is. It's right around the pivot. So the reason is we did not move our health bar in the viewport to be above the enemy's head. So let's go ahead and do that now. All right. There we go. And now we have, everybody's got health bars. Except I cannot do anything to our enemy. So we are going to need a way to do damage to the enemy to make sure it works the other way. So at this point we have everything that we need so that we can set up our hero to be able to defend themselves. So what we want to do now is let's go ahead and give our hero the ability to attack. We're going to add an input to attack, and then we also need to create a projectile for the hero character to attack with. So let's hop in. Okay, so to add inputs, what we want to do is we're going to go to our input actions, and I'm going to create a new input action. I'm going to call this input action. Let's just do primary attack, just in case we make another attack later. We're getting so close to this starting to feel like a game. Let's open this up. This is not an Axis 2D. This is a digital bool. It's basically going to be when you press it. That's it. All right, so that is our primary attack, input action. Now we need to add this to our mapping context. We need to map keys to it, so let's do that. So under inputs, in our mappings, let's add our input primary attack. And on the keyboard mouse setup, WASD, we're going to make that a single left click. So I just click the keyboard and do our left mouse, and we need to add it for our gamepad. Now for our gamepad, for me, I'm going to make it the trigger, I think. Okay, so I just clicked that button and then pulled the trigger and it filled it in for me, which is great. So now we have a way to attack. All right, in our hero character, if we go to our blueprints and we bring up our hero character, we have begin play, we have effect health, we can implement, do we want to do this here? Let's do this on the controller actually, because that's where everything is. So here's our top-down controller. So our mouse face is in here. Let's put our attack in here. Okay. So input action primary attack. Input action primary attack. What I want to check is when this gets triggered, print string hello. So let's see if we got that set up right. I do a lot of print strings. I like to check to make sure things are working along the way. So if I left click, you can see it's printing hello. Now, interestingly enough, it printed a lot of hellos. So if we take a look at why that's happening, that's going to be important. Inside our left mouse button, we have, this is our left mouse button, and this is our input action. Our input action is a digital bool, but we are not actually using pressed. So for example, what we can do here, I'm sorry, I keep flicking back and forth. In our triggers, what we can do is we have a lot of options. We can say, is it held down? Is it hold, pressed, pulsed, etc. If we change this to pressed, okay, what I'm going to do is I'm just going to, now you'll see it only prints once, even when I hold it down. So I want this to be set up so that I can either click or hold, but point is, at this point, we know we got our input correct because it is actually printing hello. Now, what we actually want to do when we attack is we want to trigger an attack. We want to spawn a projectile, but in order to spawn a projectile, we have to create one. This is going to be fun. So let's go back. I'm going to take top down. I'm going to create a new folder. I'm going to call this gameplay. Okay, and with gameplay in here, I'm going to right click and I am going to create a new blueprint. This is going to be an actor. Okay, and this is going to be our blueprint projectile base. We are going to make a simple projectile. Okay, so projectile base is going to get a special component. And it's going to get a component called projectile movement. Now what this does is it's nice enough to handle everything to do with projectile movement for us. So one of the things I want to do, we're going to keep this simple. We're going to set our initial speed to, let's say, 2000 and our max speed to 2000. We'll just keep it like that. I do not want gravity. I'm going to turn off gravity because I want it to shoot in a straight line. Now this is cool. There should bounce. We can put in bounce and stuff like that. I also want to make sure all of that's there. Okay, great. So we have a projectile. However, we have no visual. We can't see this projectile. So let's just add a sphere so we can see this. That is a very big sphere. Let's try 0.1. 0.1, 0.1. I'm not sure how big that is yet, but let's add a collision sphere as well. Collision, sphere collision. Okay, so, and I'm actually going to move this up here. Okay, so we have our sphere and we have our sphere collision. What I want to do is I'm going to make this sphere match the size. So that's about 0.7, I think. Okay, so this is our visual. Now, this you'll be able to see this as it shoots through the scene if it's big enough, and we can adjust it. And then the collision detects when it hits something. But for right now, let's just see if we can get this thing to shoot out of the front of our hero character when we click the button. So to do that, what we're going to do is in our controller, which is here, for now, what I'm going to do is I'm going to spawn an actor from class. Okay, and the class we're going to spawn is our projectile. Projectile. Okay, and let's just save all for a second. Now, this needs a transform. So in order to get the transform, let's get our controlled pawn, get the controlled pawn. And I'm going to get the transform. Get the actor transform, and we're going to feed this in here. Okay, and the instigator is going to be the controlled pawn. We may use that later. Let's compile. Our error went away. So now, when this gets spawned, it is going to, well, it's going to get created, but unfortunately, it's not going to quite work the way we want to yet. So let's go ahead, and I'm going to show you just so you can see. Oh, actually it does. Interesting. Okay, well, hold on. That went way better than I thought it was going to go. So let's see here. What we need to do, oh, I know why. It's because we haven't turned on the collision yet, but that's okay. So what I want to do is I want to turn off my enemy. My enemy is running around. I need time to test. So on begin play, I'm not going to do the move to. Okay, so that way we can test. All right, so now that we have some peace and quiet from our enemy, oh, it is actually doing it. Look at what happens when I shoot. It moves my character out of the way. That's not what we want. But if I face this way, it is working in the sense it is shooting this projectile in the direction we are facing. This is cool. This is very cool. All right, let's do a couple things. Let's take this projectile base, and first off, we can make this a quarter of the size. Let's reset this and go 0.25. And then also we're going to change this one to be 0.25 as well. I thought I turned that on. Having troubles with the keyboard. Okay, so let's see if that sizing's a little better. Play. Okay, yeah, size is way better. We'll probably go eventually smaller than that, but for now that's much better. All right, so what's happening is when our projectile hits our player or our enemy, what is happening is it is causing a collision we don't want. So, and that's because this sphere, our temporary visual, has collision turned on. So over here on the right, we're going to go down to the collision section, and we're going to turn off generate overlap. We don't want to be able to step on it, and we want to do no collision. The reason we want to do no collision is because we don't want the visual to be the collision piece, because we're going to remove this visual later and we're going to replace it with cool effects. So what's actually going to be the collision piece is this sphere collision up here. All right, so let's go ahead and play. Now you'll notice that my character doesn't move. As fast as I can tap, we're getting there. Okay, so we have a projectile. It spawns, but we need our projectile to be able to do damage. This is where blueprint interfaces come in again, which is awesome. All right, so first, let's go back to our projectile. Remember, our sphere, our visual sphere, is no longer overlapping or doing anything. We need to take a look at our collision. Our collision sphere, we do want to generate overlap events. We do not want our character to be able to step up on, and we're going to go ahead and we are going to overlap all dynamic. That sounds good. Okay. And then what we're going to do in our event graph is when we get our overlap so on event actor begin overlap. You know what? I want to double check and make sure that's the one. Add event on, hold on, let's see here. Right click, add event on component activated, hit begin overlap. Here it is. Okay, that I knew that seemed suspect. Also, that's a much easier way to get those events. Okay, so here's what we're going to do in this begin overlap. All we're going to do is if the other actor, we're just going to tell the other actor to take damage. That's it. Okay, and then we're going to destroy our projectile. So in order to tell the other actor to take damage, if they understand it, we have to be able to communicate with the health system. So that means we need to basically implement the blueprint interface for health underneath our class settings so that we know how to do that. So in here, we're just going to type in health. We're going to tell our projectile that it also understands the health messaging system. Okay, and then all we're going to do with our other actor is we're going to affect health, and the amount, let's go ahead and go -50. Go ahead and compile and save and see what happens. Okay, we got two problems. Well, we have one problem. One is unfortunately, our projectile is doing damage to ourselves. And I don't know if it's doing any damage to the enemy or if I'm just a terrible shot. Okay, I think it's not even doing damage to the enemy. So we're going to have to take a look at this. So first problem to solve is when this projectile spawns, it is actually inside of our hero. And so as it goes to the minute it shows up, basically as a result of that, it's overlapping, and so then it will actually do damage and affect our health. So what we want to do is let's put in here a little bit of an ignore. Remember back here in our hero top-down character, when we spawn, or let's see here, in our controller. My mistake. In our controller, we passed in the instigator as our controlled pollen. What I want to do is in our projectile, if we check to see is this equal to, and actually what I want is I want it not equal to. Let's see if we can do this. Yeah, so we'll make a not out of this in a second. We want to check to see if this is equal to, and let's get our instigator. Get the instigator. Okay, so if the other actor, remember we said not equal to, so I'm going to do a not boolean, so not equal to the instigator, then it will affect the health. Otherwise, it will just keep going. Okay, so this should solve our self-overlap problem. However, there's still a chance that okay, so we're good. So we solved our health overlap problem, which is great. Now all we need is we need to figure out why our enemy is not taking damage. So this sends a message to affect health. Our enemy base does have a health component. However, it does not appear as though our enemy base is actually, it does not appear as though our enemy base implements this do affect health. All we need to do is we need to implement the event. So what we're going to do is just like, it's the exact same thing. We could copy it from our top-down character. We can literally just copy and paste this. Okay, it's going to basically take the amount, feed it into our health component, and do damage. So let's see what happens now. Oh, that was fast. I wonder what our default health is for our enemy. Let's add some health here. We have default of 100. Let's go 500. Let's see what that looks like. Oh, look at that. Okay, now let's just double check one thing. Why is our enemy... Okay, we'll have to figure out why our enemy is starting with so little health on the health bar. But overall, let's see here. Begin. Oh, I wonder. Oh, I have an idea. Look at that. Okay, so just like we had, and let me explain to you what we just saw. In our enemy, just like our projectile was overlapping our hero, our enemy, this box overlap event, the one that's in the viewport that does damage to the hero, that was actually overlapping ourselves. As a result of it, we were doing damage to ourselves as an enemy. Like, so the enemy was doing damage to itself because it was this box is overlapping the capsule. So we need to put a check in here to make sure the other actor is not equal to self. Oh, actually this isn't gonna work. Let's get a reference to self. That not equal doesn't work. Self, get self. All right, and we want to make sure that this is not true. So let's put a not in here. Okay, so as long as that's not true, it will do the damage. It will send the message. Otherwise it won't. So now if we play, we should see our full health bar. We do. So now they take damage when we actually hit them, and then they end up disappearing. So y'all, we're close. We have a game. We literally have a game. We can actually turn our enemy base back on to start seeking again, and now all of a sudden I've got to chase. I gotta get him before he gets to me. There we go. Oh, so cool. Very cool. Okay, so at this point, we've given ourselves the ability to add health to any actor in our game. We just drop a component in. That's why we work modular. And we added health bars for our enemies and our heroes. Even though we're going to be moving our enemy, we created a projectile for our hero to be able to defend themselves. Now, what I think that we should probably take a look at is adding some VFX to our projectile so that when our enemies die, we get this nice popcorn explosion something rather than them just blinking off the screen, which would be great. So let's go ahead and do that. Welcome to Intro to Niagara. Okay, so to add some effects, we're just going to start with the explosion. We're not going to worry about the effects on the projectile right now. So let's go ahead and create a new folder. And this folder is going to be our VFX. And in here, we are going to create a new, where are we? Effects, Niagara emitter. Now, the emitter that I would like to start with is, let's start with the directional burst. So we're going to create this. And this is going to be the Niagara emitter, NE, and this is going to be, let's call it death burst. Okay, and when we double click on this, the way this is set up is you can see we have our burst. It's kind of bursting out the back. That actually might be kind of cool because it'll look like it's the enemy's kind of blasting out the back. The way Niagara is set up is, you can see here, this is our preview window. In the middle, this is where basically all of the information for the emitter is, and then these are our details. Now, the only thing I want to do right now is I want to change the color. And let's just make this like 100. Okay, there we go. Maybe 200. That's great. Okay, so now our burst is set to 200. And it has a nice pop out the back. So now all we need to do is, let's compile and save this. I am going to take this and I'm going to actually create a Niagara system. Now, the Niagara system is going to use, what did we call that? Death burst. We're going to use the death burst emitter. Now, the reason we're doing this is, I'll explain in a second. Niagara system, death burst, death. Let's call it death, actually. All right, and I'm going to do that on purpose because here's what we've got to have. Niagara works a little bit like a nonlinear editor. So down here in the base, you can see in the system, we have death burst. I could actually have many different emitters within the system, and they can all do different things. We can have one for the sparks, we can have one for the smoke, we can have all kinds of stuff, and you can edit them together all within this system. And I'm just going to compile and save this, and we are going to try to add this system to our character when they're destroyed. So in our health component, here we have our destroy actor. If it's an enemy, remember? So let's just take this, if it's an enemy, and let's spawn system at location. Okay, and then what this is going to do is we're going to give it some information. The system that we want to spawn is the one we just created, the Niagara system for death. And then the location we want to get is, we can just get the owner of this component. Did we not store the owner? We didn't. Let's store the owner of the component up here. So right when we begin play, I'm going to get the owner, and I am going to promote that to a variable, and I'm going to call that the owner. The reason I'm doing this is because we are probably going to be using this a lot. Okay, and that is an actor, which is great because from here now I can drag and I can get the owner and I can get the actor location. And I can feed that into the location, and I can get the actor rotation, and I can feed that into the rotation. Now, depending on how this particle is set up, if the rotation is aligned with the actor when the explosion happens, it may actually just go out the back. We may have to adjust our particle. Let's just see what happens. Compile and save, and we'll just go ahead and save all. And now when we press play, oh, actually, I was not ready. Okay, let's change our enemy not to move. Okay, this is our enemy. We're going to disconnect our move, and I want to do another thing. We need more than one enemy because we need to do some target practice here, because I want to see the different directions that this particle may go. Okay, our enemies don't move now, so let's start with this one. So if I shoot it, it goes out the front. If I shoot this one, it goes out the front. If I shoot this one, out the front. Oh, interesting. And out the front. Okay. So we kind of, here, let's do one other thing. Let's go. Okay. I was mistaken. Here's what's happening. When we get our top-down character, let's see here, in our component health, all right, what is happening is when we get our actor owner, our owner is which way the pawn is facing. It's not which way the projectile hit it from. So we actually need a little bit more information. And the information we need is we need to know what the direction of the hit was. So let's add a variable to our, let's see here, we're in our health component. We're going to affect the health, and that is going to be, let's see here, part of our, basically our projectile is going to call this inside of our enemy base. So what we want to do is let's go revisit our blueprint interface for our health. And what we want to say is the messaging system for affecting health, a message, not only can take an amount, but we also want to take a direction. So let's take this and add a new variable, and we're going to call this, let's call this damage, or let's call it impact normal, just so we know exactly what it is. And this is going to be a vector. And then all we need to do is when our projectile, which we don't currently have open, when our projectile hits, that's in gameplay. When our projectile hits and we call the health, what I want to do is I want to get the hit, I want to get the projectiles. I want to get the actual projectile's direction. So let's get the velocity. We can get that from, let's try this. We'll use the velocity. Get velocity. Get the velocity. And I'm going to normalize that so that it is a direction. Normalize that. And that is what we're going to feed into our impact normal. Okay. So now that we have that in our enemy base, when they get hit, we just need to update our actual event in the component for our health component. So here we have our effect health. We need to add the same thing. We only need one of them. We need an impact normal. Impact normal. Normal means direction if you're new to this, but it's basically a vector. Okay. And what I want to do is I want to take this normal, and this is what I want to use for the rotation. So for vector or rotation, so let's make a rotator from X, and that is what we're going to feed into the rotation. Now we have one more thing that we need to connect. So that is our health component now has a variable in our enemy base. We need to connect that to affect health. All right, so recapping, in our projectile base, compile and save, when it overlaps, it is going to send the message to affect health to the other actor. If the other actor understands it, what is going to happen is it is going to, in the case of the enemy, it is going to say, I understand that, and I'm going to call affect health for the health component. And the health component is going to go ahead and do all the work to affect health. So with all that, let's save all, and let's see where we got to with our projectiles. Oh, look at that. It went the right direction. Let's see if that works. Oh, perfect. So now our enemies are basically getting wrecked. It's just awesome. They're getting wrecked, and the direction is the direction that the projectile is traveling, which is great. So this is actually feeling really cool so far. Now all we need to do is one other thing. We don't want our projectiles to keep going. We want them to destroy themselves afterwards, because unless they're piercing, and then even then we want to maybe consider how long our projectiles are going to survive. And let's talk about a couple things here. So first off, here is our begin overlap sphere. We're going to do our effect health, And then what we want to do is we want to destroy the projectile. And the actor it's going to destroy is the self in the frame of reference of the projectile base. So that's cool. So now we actually have when it hits our enemy, it will stop. So you can see that it doesn't keep going, which is cool. So this feels way better. All right, now I want to show you a problem, and I'm going to, this could be tough to show you. Do you see those projectiles? See them off in the distance? Those projectiles are going to live forever. That is not what we want. They're still going. Okay, so what we need to do is, let's come back here. And what happens if, how do we figure out when our projectile should destroy itself? Well, wouldn't it be great if we could just set a timer, and after say 5 seconds, the projectile just says, oh, it misfired. We can do that. So on begin play, what we're going to do is we're going to do something called set timer. And the cool thing is it pops up a name for us. We're going to set timer by event. And we're going to set our time to be 4 seconds, for example. And if that happens, let's add an event. We're going to add an event. It's going to be a custom event. And that custom event is going to be called event misfire. And all this is going to do is it is going to destroy the actor. Destroy actor. Now remember, the actor it's going to destroy is itself. When we're inside the projectile blueprint, the projectile is that self. And in order to call this timer to call our misfire, we connect these 2 red squares. So let's connect that up. All right, so what's going to happen now is when the begin play starts for the projectile, it's going to start a timer. And after 5 seconds, it is going to destroy itself. All right, so let's see what happens. If we shoot a bunch of these and eject, let's see, 1, 2, 3, 4, 5. Look at that. They all destroyed themselves. And you can actually watch it too over here in our world outliner. If I shoot, you can see down here where all these projectiles have been spawned. Watch them start disappearing. There it is. After 4 seconds, they all disappear. 4 seconds is more than enough based on, let's see how. We're going to have to zoom our camera out depending on the size of our map, but 1,000 to go. I mean, 1,000 to 1,000. I'm guessing this is, oh, actually the size of this map, that might be the case. I do think I want to zoom out the camera a little bit. But anyways, so let's not get distracted. Having fun playing our game. It's actually pretty cool that it is. Now let's see what this is. Projectile base valid, do affect health. Hold on a second. Attempted access projectile base, do affect health. We are in the enemy base. We should probably check to see if, when we do this, if this is even a valid actor. Just double check is valid. Let's see if we can get rid of that error message. So if the other actor is valid, compile and save. Press play. We're just gonna shoot a bunch of stuff. I didn't see any errors that time. That's great. Okay, so our game is really starting to look like a game. I'm actually getting pretty excited about it. But what we're going to do next is we are going to set it up so that our enemies will spawn. So we're going to create the idea of a spawner. And what that is going to do is that is going to spawn a bunch of our enemies so that we can then move on to setting up how to win the game or clear the room, so to speak. So let's hop in and take a look at creating an enemy spawner. To build this spawner, what we are going to do, hopefully you guessed it, is we're going to make a blueprint. So in our blueprint folder here, I'm just going to right click and I'm going to create a blueprint from class. And this time, what we are going to do is we are actually going to choose just plain actor. And with this, I'm actually going to call this our BP spawner base. Now, we're going to do a couple of things with this spawner that is a little bit different than what we've done in some of our other tutorials. So first things first, what we need to do is we need to put our spawner in our scene. I'm just going to drop it back here. Actually, let's just drop it right here. That's good. Okay. And then I also want to delete all of my enemies. because this is what we're going to be spawning, and I want to make sure it's working. So here we go. The way the spawner is going to work is when the game starts, it is going to start a timer. And the timer is going to, every so many seconds, spawn a random number of enemies within the radius of the spawner. That's the plan. So in order to do that, what we're going to do is on our, we're also going to give this spawner, we're also going to give the player the ability to destroy the spawner, which is something we haven't done before either. So this is gonna be a lot of fun. Okay, so first let's start with the spawning the enemies. Okay, so on begin play, what we want to do is we want to set a timer. So I'm going to set a timer by event, and for now let's just set this to every 3 seconds. And what this does is this creates a timer that we can connect to any event we want, and that event will fire every time the timer requests it, if you check looping. So if you only set it once, then what will happen is this will only go through one time. But if we click this looping button, what you'll see is it will just keep on repeating itself over and over again. So now that we have our timer, what we need is we need an event to spawn our enemies. So let's create an event. I'm going to call this add event, add custom event. This is going to be event spawn enemy, enemies. Let's go ahead and take care of that. Okay, so and then we're going to connect our timer to our event, and just for demo, let's go ahead and print string hello. So when we start, we won't see any hello. 3 seconds in, we'll see it print hello. 3 more seconds in, we'll see it print hello again. So this is just going to print hello every 3 seconds. But what we're going to do is let's just start by spawn enemy or spawn actor from class. So what we want to do is we want to spawn a character, and the class that we want to spawn is enemy. This is our enemy base, so that's who we're going to spawn. And then we need to pick a location. So a good location is some radius around our spawner. So usually a good one that we can use is location in radius. So get random location in navigable radius. This is cool. Now, when we get this location, what's going to happen is we're going to take that and we're going to feed it into our transform. But before we do that, we have to set the radius. So for now, let's go with 250, let's say. And then let's go ahead and take the origin. Now, where's the origin of this navigable radius? It should be where the spawner is, because we want the enemies to spawn around the spawner. So let's get a reference to, or we'll just get the actor location. Now remember, the actor in this case is the spawner. So self is referring to the frame of reference of the spawner. And so this location is where the spawner is in our scene. So this is going to get a random location within a navigable radius that means that a character can walk on, that is 250 units in radius. All right, and we're going to take that and we'll go ahead and we can just split this struct and we can plug this straight into our transform. Now, when we do this, if everything's working right, when we go ahead and press play, what we should see is in 3 seconds, we have an enemy, which is cool. Now you'll notice, 3 more seconds, we got another enemy. So our spawner is already working. It's finding spots within navigable radius and spawning enemies every 3 seconds, which is great. Now, why aren't our enemies moving? Okay, so generally there's 2 pretty common reasons enemies don't move. One is the nav mesh. However, you've seen our enemies move before, but it is a good time to point out that this project's a little different than some of our previous. The nav mesh is already built for us. You can see it over here on the right in our nav mesh bounds. If we press the P key in our level, it will show us all the places an enemy can go. Now, the reason I wanted to point this out was I wanted to make sure there wasn't something about our spawner or where they were spawning that was possibly causing them not to navigate. So that's one, but that's not actually the reason why our enemies are not moving. If we go back to our enemies and we scroll down in and we look at our AI. Let's try typing possess here. Okay, so notice here under pawn, we have an auto possess AI option. Now, even though we don't know it, this simple move to that we do on our enemies, that simple move to is using the AI to do that. So what we're going to do is, you'll notice that when we do that, right now it's on placed in world. We need to change this to spawn because we're no longer hand placing these in the world, we're spawning them instead. So let's just compile and save that and give that a shot. See if they start chasing me now. Nope, we're still missing something. So let's make a couple updates here. Oh, we actually, the thing that we were missing is we forgot to reconnect our simple move to actor. Okay, so if we reconnect that, hopefully then that's the trick. Nope, yes, we do. Oh my goodness, and they're so fast. That is ridiculous. Okay, now the one thing I did want to check was, I just wanted to double check, show you all. If we go back to our class defaults for the pawn, let's see if I can find it without. All right, let's just do the possess again. If we switch this possess to placed in world, let's see if this still works. I've had this not work before. Yep, so that does confirm it. Placing in, because we had the setting set to placed in world, it didn't, we needed to change that to spawn instead. Okay, so really what it was we just had disconnected this for testing purposes. Okay, so now our spawner is actually spawning our enemies, and we actually are starting to get to a point where we have a game, except they're so fast I can't get away. So now that they're spawning, what I want to do is I actually want to change how many of them spawn. So remember we had said, let's go ahead and randomize how many spawn, and then let's also make our enemies a little bit easier for us to destroy. So I'm going to knock, while I'm here, I'm going to knock their health down. Let's see here, health component, default value. Let's try 250, for example. Okay, and then let's go back to our spawner, because this is all about the spawner. So every 3 seconds, we're spawning an enemy. Well, what if we wanted to spawn more than one enemy? So here's what we're going to do. We are going to create a for loop in here. So let's go for, and I'm going to use a regular for loop because this one works with numbers. So if you don't know what a for loop is, we have a whole series on for loops and arrays, but basically what this is this is going to repeat something so many times. In this particular case, what I want to do is I want to get a random number of times. And the random integer in range that I want to use is, let's say we can spawn between 0 and maybe 5 enemies. That might be intense. 5 of these characters running around. Okay, so what's going to happen now is the game's going to start, then the timer is going to start. 3 seconds later, it's going to spawn enemies. Every 3 seconds, it's going to spawn enemies. It's going to get a random number between 0 and 5, and that many times is this for loop. For each 0, 1, 2, 3, 4, 5, it goes through, finds a random location around our spawner, and spawns an enemy. So let's see what that looks like. The first time was 1 enemy, 2 enemies. Oh wait, they're actually killing each other. Oh, I didn't even see that. Okay, that's awesome. Friendly fire. Okay, that's working. So we're getting more than 1 enemy, which is great. So this is definitely working. Now the one thing that is happening is they're instantly appearing at the same time. So what we could do is we could possibly try something like to put a delay in here. However, the problem with the delay is sometimes for loops don't work with delays, but let's just try one and see if we can actually show you the example. Delay of, let's go 0.5, so it's very obvious it's happening. So we're only ever getting 1. I know it seemed like a while that I was thinking, but we're basically only ever getting 1 enemy. The reason for that, there's no way, the odds are against us with this kind of for loop. So this delay, what's happening is it comes in here, it tries to do this for loop, and it does it within a single tick. And so what ends up happening is it does the first one, but we never come out, we never finish our delay. So if we want to stagger our spawn, what we could do is we could create a new function that is, or a new timer that staggers our spawn, for example. So there's a couple different ways we can do this, but let's just go ahead and do this. Let's create, okay, so we have our timer by event, and this is going to fire every 3 seconds. And then what we could do is we could create another timer by event. Let's do this, timer by event. Getting wild, but the repetition will be good. So let's just take all of this and move it down. Okay, I'm going to disconnect this. And then what I'm going to do is I'm going to set this timer to be 0.033 is 1 tick. So let's just say we want to split them up by a tick each. This also is good because then we're not spawning all of them at the same time, so the game's not loading them. So let's add a new event. This event is going to be event stagger spawn. Okay, so this is going to trigger repeatedly every tick, basically every 0.003 seconds. Now, this is where we need to change how, or the number of enemies to spawn. What we want to do is we want this to be basically a value that we can tick down. Okay, so here's what I mean. Let's set this to let's set this to a variable. So we're going to promote this to a variable, and we're not going to call it last index. We're going to call it num enemies to spawn. All right, and then what we're going to do is we are going to get a random integer in range between 0 and 5, and then we're going to set our number of enemies to spawn. Now we're going to be getting rid of our for loop as well, but before we do that, let's just walk through this. So now we have a random integer between 0 and 5. All right, and actually I'm going to bump this up 3 to 5. So it's going to spawn 3 to 5. Then it's going to set this timer that's going to start ticking. Basically, it's not a tick, it's a timer every frame. We could also put this on tick, by the way, but just for kicks, let's just keep going here. So then what we're going to do is we're going to set timer by event, and we're going to start spawning. Now, what we want to do is we want to, let me move this for loop out of the way. Let's get the location, or get the random point, and then we'll spawn the actor, and then I want to take the num enemies to spawn, and I want to decrease it. I believe we can just do a minus on this. Yeah, we can just decrement this. Okay, so decrementing is just the same thing as subtracting 1. So what this is going to do the first time through, let's say we had 3 enemies, it's going to come through event stagger. It's going to get a random location, and it's going to spawn an enemy, and then it's going to take number of enemies and set it to 2. Then it's the second time through, it's going to come through, it's going to set it to 1 and then to 0. So what we need to do is we need to put one more check in here. So let's get our number of enemies to spawn, and let's check to see if it's greater than 0. If it's greater than 0, we will do all this. So we can basically get rid of our for loop. And I'm going to hold the B key to get this to pop up. B for branch. So if it's greater than 0, then it is going to spawn. Now, this particular setup, it's important to understand there are many ways to do the same thing in Unreal. A lot of it is going to be based on your project, what you're doing, etc. So, like I said, we could use ticks since we're doing every tick, but maybe we set that out to stagger even more. So in the first second, we should get, there you go, you saw them kind of pop up. All right, so this time let's make it even more pronounced. Let's go 0.099. So that should be 3 frames between. So let's just see what that looks like. There we go. That looks good, right? Even that feels good. I think that's a much better spawn rate because they come in a little bit offset. That feels really good. What a happy accident. Just double checking if there's anything else I want to do. Okay, cool. So what we now have is we have our spawner, it comes in 0.3. What I would like to do is I would like to make this a variable that I can control. So let's do this. let's take this max number of enemies and let's right click, and I'm going to promote this to a variable, and I'm going to call this max enemies. And I want to make this instance editable and expose on spawn. The reason I'm doing that is because what I want to be able to do is I want to be able to have more than one spawner. So let's just say we have this spawner over here. Right now, if we look at the defaults, you can see here, I can now set max enemies, which is great. So now I don't have to go back to the blueprint to make changes. So if I set my max enemies to 1, now I can move or make a duplicate. I'm going to alt drag to make a duplicate of this spawner. I'll put it over here in the pillars, and I'm going to change my max enemies over here to 5. Now what that's going to do is I should get 1 every now and then from here, and many more enemies coming at me from the right on this one. So that is why we exposed that variable to instance editable and exposed on spawn. So let's just see. There we go. We had 4 enemies come at us from the right. Oh, I managed to survive that. 1 from the left. So this way I can set up, I can now spread these spawners all over, and I can control how many enemies are spawning, etc., which is great. Now we can do a couple more things in the same vein. Let's change our, this is not the spawner. Okay, here we are in our spawner. Let's change our spawn interval for our enemies. So promote this to a variable, and I'm going to rename this to spawn delay. Spawn delay. So that's another good variable that we could use, and that's instance editable and expose on spawn. So now we can have enemies that spawn, or we can have a spawner that goes faster or slower. Now, one thing to mention, this spawn delay that we're using right now, or this stagger, this is our stagger timer. It's important to understand. This stagger timer is if you spawn 100 enemies and it takes 0.1 seconds between enemies, what you end up with is 10 seconds, right? 10. You end up with 10. What you want to make sure is you got to make sure your spawn delay is less than you're setting your timer by event, because otherwise what ends up happening is you just keep stacking these things. So there we go. Now the other thing that I want to do here is, so now we have a spawn delay, which is great. Now the other thing I want to do, speaking of cleanup, is when we begin play, this is our overall timer for spawning enemies. This will get destroyed when we destroy our spawner. When we come down here to spawn enemies though, every time we trigger this, every 3 seconds, it's going to start a new timer. Okay, now fortunately that timer is going to be very fast, but when the timer is done right now, we're not destroying the timer. So let's go ahead and destroy this timer. So I'm going to right click and I'm going to promote this to a variable, and I want to rename this to be stagger timer handle. And the reason we've done that is because when we're done, if it's greater than 0, we're going to spawn, but when we're done, if it's not, what I want to do is I want to clear and invalidate the timer handle. Now, technically we might be able to reuse it, but just for ease right now, let's just go ahead and clear it. So this way we're cleaning up this timer that we're creating right now every 3 frames is basically what it's approximate. Okay, so we've got some variables. We've cleaned up our spawn timers. Let's just go ahead and double check and make sure we're good. Yep, everybody's still spawning. Oh, they're getting close. All right, don't get lost. All right, so that's looking really good. So now we need a way to destroy our spawner. Now the cool thing about it is our spawner is an actor, which means we can put components on it. One of the components that we've made, if you recall, is a health component. So we can actually add health to our spawner. Now we're going to need a couple other things with the spawner in order to be able to know where it is. We're going to need a visual. We're going to need to be able to hit it. There's a bunch of stuff in order to do damage and destroy it. But we definitely need health. So by default, our spawner is going to start with 100 health. And then what we want to do with that is add a visual now so that we can find it. We're going to keep this easy. Let's go ahead and add a static mesh. And the static mesh that we are going to choose is going to be something fun. Let's say Let's do a chair. We're going to spawn our enemies out of a chair, for example. Okay, let's double check and see how big it is. There's our chair. All right, great. Now, here's the thing though. We need to make a couple changes to the static mesh because the static mesh also has collision. See how it has all block, all dynamic and everything on it? This could cause problems with our enemies. Let's just see what happens actually. Nope, they're good. Actually, it's probably good that we keep that mesh there. All right, so we'll just keep that. The thing I was going to say though is if you add collision, for example, you probably will need to change these values. So what you can do, for example, let's just go ahead and do it. Let's add a collision. We're going to put a box collision in here. And the reason I'm doing this is because we're probably going to use this to help us with the damage. So let's just do this. Like that, for example. Now, then what we can do with our static, and I'm going to reparent this to the scene root. And then for the static mesh, I'm just going to not generate overlaps. We're not going to step up on, and I'm going to do no collision. And then for the box, what we will do for our collision is can character step up on? No. Generate overlap is fine. Overlap all dynamic. That sounds great. All right, now what I'm curious about is can we actually shoot? Yep. So our projectiles are hitting the spawner. They don't do damage yet. And that's because we haven't connected anything to tell our spawner to do damage or receive damage. So what we need to do is we need to tell our spawner how to listen for the messages that are coming as part of the blueprint interface for health. Remember how we did that? In our class settings, we implemented or added an interface. In this case, we're going to call health. And when we do that, we get our interfaces over here on the left. And in our event graph, we can actually now implement do affect health. So let's implement this event. And if you recall, since we have all of this already done, all we have to do is affect health. And then we can feed in the amount and the impact normal, and this should affect the health of our chair. Now, if we hit, which isn't a chair, it's our spawner, but if we hit our spawner twice now, we should be able to destroy it. Nope, not yet. So let's do a couple things. Let's figure out what is going on. We're definitely hitting it. Let's see. We come in here, we are affecting health component. That all looks connected. My guess is there's something about our collisions. Okay, I think I figured out what it is. Everything we're doing in here is fine. All of our settings for all of our collision are fine. But look, let's take a look at our health component here for a second. Okay, our health component, if you recall, when we built it, we basically set it up so that on begin play, it checks to see if it's an enemy. And if it's an enemy, then it sets it as true. And then it checks to see if it's a character, and if it is, it gets a controller, it casts a controller and sets the player. And if it's not an enemy, which it's not, it casts a character, and then if it succeeds, it gives the player controller. But what if it's a spawner? So I think what we're going to have to get a little smarter about how we're doing this. What we could do for the purpose of just moving forward right now is if this fails, we could actually take this and we could check to see if we could cast it to a spawner, for example, spawner base. And if that's the case, then what we can do is we can set is enemy to true. And what that will do is now down below, actually, let me make some room here. When we go through our affect health function and we get to the is enemy part, what we'll do, it will go straight to true. All right. Whereas before it wasn't an enemy and it wasn't a player. So it would come down here, it would fail, and then it would do nothing. All right. So we just need to make a quick change in here. So let's go ahead and set enemy to true. And there's another way we could do this actually. But for now, we'll just keep it like this because I think it's a lot simpler to understand. But you can see, you don't want to sit here and nest all of these, right? We want to find probably a better way to do that in the future. So for now, let's just go ahead and see if we can destroy our chairs. Oh, there goes a chair. And we got it. We just won our game. Aced it. Okay. So let's see where we are with our spawners. We can, in our scene, we can set it up so that on each spawner, we can determine the max enemies, the spawn delay, everything like that. We should add a health bar. That's what we need. We need a health bar. So for our spawners, what we're going to do is we're going to add a widget just like we've done before. And this widget is going to be in screen space. And we can leave all of that stuff there. And then on begin play, in addition to our timer, we are also going to create a widget. And the widget we're going to create is a health bar. And we're going to give it the health component. You can see how we're reusing all this. We're getting a lot of this stuff super fast and free just because we've created these components and widgets and all kinds of stuff, which is fun. Okay, so then what we're going to do is we're going to set widget. And that is going to set our widget for this to be the widget that we populated. And let's just see where this is in our viewport. If we pick our widget, right now it's below the chair. Let's just move it above the chair. Compile and save. Let's actually save everything. And we'll go ahead and click on play. Now our chair now has health. Look at that. Our chair has health. Our spawner, I should say. I guess I already killed. Yep, I already destroyed the other one, and I just won the game again. So now if we just want to have one last fun deal, we can actually take these. We can spawn them from all sides. Our game's really starting to shape up. Okay, so they can come at us from any direction. Oh, didn't even make it. Didn't even make it. Okay, don't want to get too lost, but you can see how what's happening. We're good to go. So we very quickly took our spawner. We've got it spawning enemies. They're even stagger spawning, and it has a health bar. We can destroy it. That can be part of how we clear levels. Maybe that's going to be the condition. All enemies are dead and all spawners are destroyed, and then you can actually leave the level. Who knows? We'll figure it out as we go. Now, there is one other problem that I want to address before we move on to the next section. And what that is if you notice, our enemies, I'm not firing a single projectile, and when our enemies hit each other, they're doing damage to each other. They're literally running into each other and doing damage. We don't want our enemies to do damage to each other. So on our enemies, if you recall, this box is the one that's doing the damage. And on our event graph, if we do the overlap, we check to see if the other actor is valid. We check to make sure it's not ourselves. But what we should also do is, let's in this case check to make sure that it's not an enemy. So what we can do is we can get the class, and what we can do is we can check to see that it's not, let's see if we can do not equal. Yes, we can do not equal to enemy base. All right, now why this is cool is because then what we can say is if it's not ourself and it's not an enemy, and we use the ampersand and here, so, or you can type in and, we get the and, then affect health. So now what should happen is let's clean up our noodles here just a little bit. We should actually be able to see that our enemies are not, if I can survive long enough, we should be able to see that our enemies are no longer damaging each other. They're not. Looks good. Holy smokes, looks good. I just got wrecked again. So we got it. We got our spawners working. They have health and everything. This game is almost there, but that does mean we need a way to win this game. So to do that, let's take a look at our game mode now. We need to set up some of our win conditions and our lose conditions before we get into the UI to show it all. So our game mode, as you've probably guessed, is a different kind of blueprint. Now, the interesting thing about the game mode for the top-down shooter is, unlike if you followed our horde mode minigame, we don't need to create it from scratch. The reason being is the top-down shooter already has a game mode created for us. So if we take a look in our blueprints folder under top-down, you'll notice in here we have a top-down game mode. Now, this game mode is actually currently being used in our level settings over here. Usually you're looking at the details, but if you click on world settings, you can see this is being used as the game mode override. So that's how we know we're using that game mode, and that's what's actually being set up when we start and use our game. Now, if we double click on this, if you come in here, you may see just a single screen that shows just the details. If that is the case, and this just kind of depends on your settings, you may have to click the little blue text that says Open Full Blueprint Editor to get a view like this. We're going to want this because we're going to be making some changes to what our game mode has associated with it, variables and things like that. But over here on the right, we have all the classes that are associated with our game mode. The session, the state base, the controller, the player state, the HUD, which we're going to be changing later, etc., etc. Now, what we want to do for the game mode is we want to control all of the win conditions, keep track of the score, figure out when a level is complete, all those kinds of things for our game. So to do that, we need a couple variables. Here are some variables that I would like to add. One, let's create a score. This is going to be an integer. And two, I would like to create one called number of spawners. Because what we're going to do is we are going to set it up so that when a spawner gets created, it registers itself with the game mode. What I mean by that is when a spawner starts, it is going to tell the game mode, hey, I just started. The game mode is going to say, ooh, I have one spawner. Then the second spawner is going to come along and it's going to say, I am spawning. Then the game mode is going to say, ooh, I now have two. Then as the player destroys the spawners, when we get down to 0, that should end the level and win the level. That's what we're shooting for. So to do that, we need to keep track of the number of spawners. And what we want to do is, let's create an event. And I'm going to add a new custom event. And I'm going to call this event increment spawner count. Okay. And all we're going to do when we come in here is we're going to take our number of spawners and we're just going to do plus plus. Now, this is the same exact thing. This plus plus, just so you know, literally is the exact same thing as taking this spawner and adding 1 to it. Not 11, 1. All right, but this is just a quick way because it's such a common thing that we do. We have an increment. Now, interestingly enough, we also have a decrement, which does the opposite. It subtracts 1. So let's take this. Let's add a new custom event. And this one we're going to call whenever a spawner gets destroyed. So we're going to call this decrement spawner count. And what we're going to do in here is we're going to take our number of spawners and we're going to minus minus, decrement int. Now, the other thing that we want to do in here is we want to, if the number of spawners is less than or equal to 0, you win. So right after this, we're going to go ahead and say less than or equal to 0. And if this is true, let's go ahead and print a string saying you won. You win. Now, eventually we're going to connect this to an entire victory and defeat UI, etc. But for now, this will tell us that this is working. Okay, so we have our game mode. That's great. It increments and decrements spawners, which is awesome. We'll get to score and stuff like that here in a second. Now, what we need to do is we need to update our spawners to tell the game mode that this is all happening. So to do that, what we could do, one thing we can do is we can go into our spawner base and on begin play, what we're going to do is we're going to get the game mode. Let's get the game mode. And with the game mode, we have a couple options. We could just cast this to a top-down game mode. And by doing that, we can now call the event increment spawner count. Now, the reason we have to cast this is because not all game modes have this spawner count. I have to make sure it is a top-down game mode. So if I tried to drag off of just the game mode and type increment, nothing shows up. We have to make sure it is a top-down game mode first. Now, before we do this though, I'm going to go ahead and promote this to a variable because we're going to be using this and I don't want to do the cast every single time. So here's what we'll do. Let's disconnect this, reconnect this. Everything's connected. And I'm going to change this to just game mode for now. And there we go. So now when we begin play with our spawner, we're going to get our game mode if it's valid, and we can cast to it. It's a top-down game mode. We're going to set a variable, and then we're going to increment our spawn count. So in our current level, we have 4 spawners. Now, we also need the flip side. We need to be able to, in our spawners, when they get destroyed, we need to tell the game mode that they got destroyed. So let's go ahead and go down here, and here we are. We're affecting the health, and let's see here. We could basically just say, after we affect the health, this is going to get destroyed. Let's see if there's a add event. I believe there's a destroy actor event. Yes, we're going to do this. So when our actor gets destroyed, what we're going to do is we're going to get our game mode, and we are going to decrement the spawner count. And there you have it. So what should happen is our effect health is going to go through, do what it normally does, and then when it destroys the actor, this will actually get called and it will decrement our spawner count, theoretically. So let's give this a shot, and we're going to have to do a good job. So that's one spawner. Oh, there. Okay, I am way too slow at shooting. So actually, can I just hold it down now? Oh, we didn't do that. We should do that. Yeah, our game's too hard. I can't do this. So I'm going to change it so all of our spawners spawn. Let's do this. Let's go. How many enemies do these spawners spawn under details? I'm going to change our max enemies to 1 on all of these. So let's just take all of these to max enemies 1, max enemies 1, 1, and 1. Okay, now we can try again. What we're trying to do is we're trying to destroy the spawners so that we can check to see if we won our game. All right, now we should see after we destroy this one. There you go. You see it print in the top left? It printed you win, which is awesome. So that actually totally works. That's great. So that's going to be our win condition, and that's what we needed in order to build our UI. Now, while we're in here, since we're working with the game mode, let's go ahead and do the exact same thing, but this time for score, because we need to keep track of our score. So here's what we're going to do. We are going to add a new event. Add a event. This is going to be custom event. We're going to call this event. What should we call this? Score, adjust score, effects. Let's call it effect score, for example. And we're going to take, this event is going to take one input, and we will take it as a score, or let's just say amount, maybe amount, and then we will make this an integer. Okay, and then what we'll do is when we come in here, we're going to take our score, the current score, and we are going to add to it a value. Now, realistically speaking, why would we reduce the player's score? The only types of games I can think of that you might do that in is, for example, if you're doing a shoot 'em up and there are civilians in it or something like that, and you accidentally hit one of the friendly targets, then maybe your score goes down. All kinds. But either way, the point is, if amount is positive, your score is going to go up. If it's negative, your score is going to go down. So then what we're going to do is we're going to set our score to be the result of that. So then all we need to do is the exact same thing in our enemy. If we go to our enemy base and we want to, or actually we can affect our score with our spawners too. So let's say enemies, first we need to we'll start with the enemies. First we need to get our game mode in here. Let's get the game mode. Get the game mode. And then we're going to cast this to a top-down game mode. If it is successful, we will promote this to a variable. We'll set it, and then that's all we need. Okay, so let's just change this to game mode. Okay, so then what we want to do is we want to, whenever we affect health, let's do the same thing again here. We're going to add into the event destroyed, add destroyed. We're going to take the game mode and we are going to adjust, or let's do score. We're going to affect the score. Now, this is where we get a little bit interesting. So we want to affect the score by a certain value. Let's just say that enemies are worth 100, for example. And then what we could do in our spawner, we could also adjust the score or affect the score. And what we're going to do here is maybe spawners are worth more. Maybe spawners are worth 200. Now you can really pump up your score by letting more enemies spawn, for example. So let's move this up, align these, pressing the Q key. So now we should be incrementing our score. We don't have any way to display it yet because we don't have a UI. So what we'll do is in our game mode, anytime we affect the score, let's just go ahead and print the current score, just so we can see it happening. We'll keep our win condition there, compile and save, and let's test it all out. But first we're going to save all. Okay, so 200, 400. Okay, our enemies are not, oh yeah, they are 600. Let's just double check. We should get 100 for enemies. Our random number of spawns is, there we go. 800, you win. Oh, wait a second. I didn't get to see that. Let's try that again. All right. I didn't see that one print, did you? Nope, I didn't see that one print either. We need to run that again. You know what? Let's just double check that we're hitting that with our enemies. It's possible that our enemies are getting destroyed. Wait, where is our enemies? Oh, we put this in the wrong. We put this in the wrong place. Okay, so we put this in our top-down character, which is ourselves. We don't want to get points for ourselves. We'll keep this game mode in here. We may need it for our top-down character, but we do want to actually put this in our enemy. So we're going to do this one more time, and in our destroy, let's see here, begin play. Let's get the game mode. Get the game mode. Cast it to top down. Go ahead and with that, promote that to a variable. And then we'll go ahead and make that game mode. Now, with that, just like we did before, and we're going to add an event for destroyed. Did I just copy and paste that? Ah, here it is. Okay, so now let's get destroyed. Where's our event? Destroyed. We'll go ahead and set that here. All right, one more test. Here we go. Get this first spawner. That should be 200, 300, 500. There we go. Now it's working. And we don't get points for getting wrecked ourselves. We'll wait for one more just to double check it. All right, I believe. So we can, ooh, we got a runtime error. Game mode, event effect score. Ah, interesting. Okay, so let's go ahead. We do need to maybe put in here a check. Let's just make sure the game mode's valid. So not is valid, I'm going to use valid. This usually happens if your game ends and it's still cleaning up, for example. You've destroyed everything in the scene, but it's still, as it gets destroyed, it tries to affect the game mode, but the game has ended. So there's some stuff like that. So we may want to do the same type of thing in our spawners. Although our spawn base, let's go ahead and double check before we do all of this if our game mode is valid. A little bit of noodle cleanup, and then let's go valid, just to be sure. All right, so if all these things are true, we should be good to go. Let's go one more run. This guy's gonna get me. kill that one. All right, no more errors. Perfect. Okay, so we've set up our game mode. We have our score. We have the ability to win the game. We're not going to do the UI. Well, we are going to do a little bit of UI first, but the first UI that we're going to do is, I thought it would be cool to do one form of damage numbers as part of this little mini game. So what we're going to actually do is we're going to add it so that when we shoot an enemy, the damage numbers pop up. And the way we're going to do that is with our health bar. Now, there's a lot of different ways to do damage numbers. I think that this one is probably a great one to help wrap your head around. So here's our health bar. And when I say there's other ways, you could do it. You can do it with the particles, for example. You can do it with spawning individual widgets. The problem with the particles ones, it's not a problem. It's just it's a deep rabbit hole. So this is a cool way to do it, and it'll teach us a bunch of stuff about UI. So here's what we're going to do. In our canvas panel, we're going to go ahead and we are going to add an extra text. And this text, what we are going to do is we are going to default it to zeros. Let's go, sure, I don't think this size matters. Let's go ahead and set our anchors though to be the middle. And then we need to get all of our offsetting. And then the text also needs to be center aligned. Now we still have, there we go. Okay, so our text is now in the middle. I believe we probably have, all of our anchors are good. Okay, great. So here's what we're going to do. Here's our damage numbers. We are, if you look down in the bottom, usually it's on the bottom of the designer, or there's a button here on the left. You can click on your text, and there's a tab for animations. So what we want to do is we want to add an animation, because what we want to do is when we show damage numbers, we want the damage number to kind of pop out of the enemy's head. So let's add an animation, and it's going to be the damage numbers. All right, when we click on this, we're going to add a track, and the track that we're going to add is, I think, I'm going to go ahead and make these damage numbers a variable. These are going to be text damage amount. Okay, and what we're going to do with the damage amount is we are going to add a track for the text damage amount, but not the text. Yep, the text. And then in here, we're going to add a track for two different things. We're going to do one for the transform. Give me a second to find it. And then we're going to do one for the color and opacity. All right, so let's start with the transform. The way animation works in this UI is this is our timeline. It goes back and forth. We're starting at frame 0. We need to set keyframes at frame 0. These are where it starts. Okay, and then we need to go forward some amount of time. Let's go 1 second, for example. And all we're going to do is we're going to animate this transform. So let's just animate this upwards, for example. Okay, now when we do that, this is probably set to single. I'm going to set this to looping and press play. So you can see our damage numbers are now going upwards. All right, now we can make this a little more interesting by adding in an extra keyframe here, where what we can do is we can take the 0.75 mark and middle drag it back and set a keyframe on our Y value. And what that's going to do is that's going to give it a little bit more of a pop effect, right? It's going to rush up a little faster. And what we could do is we could make this even more extreme. So it gets a nice like kind of drift to the top. Go even more actually. Okay, and then overall, I think we're going to need to shorten this. Okay, cool. So now that we have that, let's go ahead and go here. Cool, that feels good. Now what we also want to do is maybe we also change our opacity. So we're going to start 100% alpha. So let's just stop playing so we can actually do this. We're going to start with our alpha is the transparency. If you're not familiar with colors, there's red, green, blue, and alpha. Alpha is how transparent it is. So if we set a keyframe on our alpha, what I want to do is we're going to keep it at 1 to about here. So I'm going to set another keyframe by clicking this button. And then by the end, I want it to fade out completely. So let's drop this to 0. So now what should happen is you'll see it kind of fade out. Now that's a little bit harsh. So let's see if we can smooth that out a little. I think that feels good. Okay, now what we'll do, so here's what we need to do. Now that we have this animation created, let's compile and save. We need to do a couple more things. We need the ability to trigger the animation. We need to be able to tell the system, hey, play this animation whenever damage is done. So what we want to do is we're going to add a couple events here. One, well, even before we add some events, what I'd like to do is I would like to, yeah, let's add a new event. This one's going to be a custom event. This is going to be event show damage. Let me zoom in a little bit so you can see this. And then what we'll do with this show damage is we're going to do a couple things. We want to give this an input. And the input's going to be damage amount. And this is going to be an integer. And we're going to take this damage amount and we're going to change our damage text. So with our text damage amount, we are going to set the text to be this value. So this is going to automatically convert it. The text is text. The damage amount is an integer. So what we're going to do is we're going to go ahead and set that. Now, once we do that, now we can actually call set damage amount. So let's compile and save that. And I don't think we're going to see, yes, we do see the numbers above our head. We're going to change that so we don't see those in a second, but at least they're showing up. That's great. So we get that for free. Now what we do need to do though is we need to, in our health component, let's see, is this where we want to do this? Let's do this in our enemy base actually. When we affect the health, this is where we are going to trigger the damage amount. So to do that, what we want to do is on begin play, we create this widget, we set this widget. I want to set a variable so I have access to this health bar widget. So let's promote this to a variable. And this is going to be our health bar widget. Let's call this health bar widget, for example. That way down here, after we affect health, what I can do is I can take the health bar widget and I can run an event, show damage. So here's what's going to happen. We're going, and this float is going to get converted to an int. So now when we actually do affect the health, we're going to see the damage numbers changing. They're not going to animate yet. We're going to do that here in a second. So see how it's changing? So now it's minus 50. For now, we know we're changing the numbers. Now all we need to do is we need to trigger our animation at the same time. So what we can do is we can take this damage numbers animation, which is underneath our animations now, and we can, I believe it's play from, let's see here, play forward. Cool. So if we do damage, we're going to go ahead and play the animation now. We are so close. Okay. Where's our enemies? Look at that. Look at that. Oh, did you see that? That was cool. Okay, now, every time we hit them, we're getting a damage number. Now, the damage number is going a little bit high because of our perspective. So what we can do is we can come back to our animation in our designer and we can adjust this. So this height that this is traveling to is a little bit too much. So if we take a look at our translation Y value, you can see where it's getting to. The problem is if I affect just this one piece, really what I want to do is I want to affect the curve. So you can click this curve editor, and if you look at this, we look at our transform, our translations, you'll notice that this is our translation curve. I'm going to take both these values and I'm just going to move them up. Let's try half. Okay, so that way I can adjust both keys at the same time. Let's see what that looks like in here. Oh wait, I did not mean to click that play. I meant to click this play. That still feels good. Okay, let's see what that looks like in the viewport though, because we kind of want them to stay on screen. Oh yeah, that's good. We could probably go a little bit less, but that's good. So you can see we have our damage numbers playing. So here's what we need to do. There's a couple more bits that we need to do. If we take and we don't want to see the numbers when we start. We only want to see the numbers when the damage is actually shown. So when we start on our construct, let's see here. Event construct. What we can do is we can take this text damage amount and we can set the color and opacity. And what we're going to do is we're going to set the opacity to, so let's make this. So let's make one of these. Make a slate color. Okay, and the color that we're going to use is going to be, we can keep it, let's do red. We can do red, sure. And then for the alpha, let's go 0. Okay, so what's going to happen is when our health bars are constructed, it's going to set the default value for the text to be, should be red and also invisible. So we should not see any text when we start. But when we do damage, let's see here. There we go. Now we got it. Now, they're not red though. That's interesting. So are we setting our color value as part of our designer? Yes, we are. So we're setting our color and opacity for our damage numbers here. So if we were to change this, if we go back to the beginning and we want red, we can go 0, 0 like so. So now we'll get red numbers. So those were effectively overriding what we had. Now, we're not getting our damage numbers on our spawners right now. There we go. Honestly, the red's a little bit hard to see, but it's fine. Let's not belabor that point. That all works. I would actually probably take this transform a little bit lower. Still seems kind of a lot. Compile and save that. And let's do the exact same thing for our spawners. Super easy to do. When we affect our health, all we're going to do is do damage. Let's see here, not our health component. What we need to do is up here, when we begin play, before we set the widget, we need to do a similar thing. What we want to do is we want to promote that to our variable. And this we called, what did we call that in our enemy? We called that health bar widget. Just be consistent here. Health bar widget, health bar widget. Now, this could be a good thing that we would potentially want to just put in as a component or part of our component so that we're not redoing this work everywhere we want to. But for now, it's good repetition. So we have our health bar widget. So all we need to do with that health bar widget, we'll get that and we will go ahead and we will damage. We'll show our damage. So now when we do damage to our spawners, they will also show the damage. Compile and save that. And we should be in a good place. There we go. Interesting. I think because of the location. Nope. Oh, they're still there. I think it's just hard to see that when they're red. So, okay. We got a lot done so far. So our game is close. We have all the pieces we need to win. We even have a you win option. But what we really need to do to kind of put a bow on this whole thing is we need a little bit of UI work. So it would be great if we could show our score, our health bar, a victory, a defeat, a pause screen, and we could restart our game. So with that, we're going to be doing a bunch of UI work. So let's hop in and check out a HUD. So to create our UI, as before, we're going to be actually doing two things. We're going to be working with widgets, and we're going to be working with HUDs. So let's start by giving ourselves a HUD. So if we right click and we do new blueprint class, we can go ahead and we can choose, we can type all classes, and we can type in here HUD, and we're just going to select HUD. I'm going to select this, and I'm going to call this HUD, and this is going to be our twin stick shooter. Yeah, we'll just call it HUD TSS, twin stick shooter. Okay, now that we have our HUD, if we open this up, what we're eventually going to do, let me bring this over here. What we're eventually going to do is in the event graph on begin play, we're just going to spawn our, we're going to create our widget and add it to the viewport. So that means we need a widget. So let's go back and we're going to create a widget, kind of like we did before with our health bars. But in this case, let's just go ahead and bring this over, create a user widget. We're going to call this widget blueprint TSS HUD. Okay, now in our HUD, once again, remember what we need in our widget. I'm just going to call it the widget from now on, just for clarity. So in our widget, what we need, if you recall, is we need a layout, or they're usually called panels, to work with. And these are all our panels, canvas, grids, etc. We're just going to reuse the canvas panel, and we need a couple things. Let's put a score in the top right. So that means we need some text, and for now we can just drop this into the canvas. Okay, and with our text, what we're going to do is, let's see if we can adjust our anchors so that it's basically the entire top of the board, which is cool. And then if we change our offset right to nothing, and we do 0 and then 0, well, keep pressing the arrow key. Okay, so now this stretches the whole length of the top of our window, which is great. And all we need to do is we need to get our text to align. We're going to want it to align to the right side. So let's see if we can do this by font, color, outline settings. I feel like I'm missing my font alignment. Here it is, right. There we go. Down here when we get back to shadow brush, etc., we can get our justification. Okay, so now our score is always going to be in the top right. I'm going to change this to a bunch of zeros just to start with, so we have it. And I do actually want a little bit of padding. So let's give ourselves, I don't see padding in here, so we may need to wrap this to get our padding. Yeah, we don't have that. So let's see if we can do a quick wrap on this. We may undo this. So let's wrap this with a border. And here's our border. Our border does have padding, which is great. So let's give ourselves a padding at the top from 50 and from the right of 50. So our score is going to be kind of slightly offset, so there's room to read it. We can adjust our font size and everything like that later. So that gives us our scoreboard, and we can actually label this. Let's label this so we know it is. This is going to be our text score, and I am going to make this a variable. Okay, so we got our score. Now let's add our hero health bar to the bottom here, and we're going to do that once again with a progress bar. We're going to set this just like we did our previous progress bar, and this one we are going to drop down. We're going to try anchors at first, so let's go bottom of the screen, and then let's kill all of our offsets. So now our health bar is spanning the entire width of the screen. That's not quite, that's not quite what we want. Okay, we have size Y, that's great, and let's see if we can maybe consolidate this down a little bit. What I'm going to do is I'm actually going to wrap this with I'm thinking horizontal box, because I'm thinking about dividing the HUD up into 3 sections, either a left padding, a right padding, or what we could do is we could just wrap this with the border as well. And in our border, we can change our padding, or now that we have our border, we can change the padding on our progress bar to say 100, maybe 500, and let's go 500 on the right. So our progress bar is now going to scale to the size, and I want to change the content and the color opacity of our border. I don't even want it visible. Wait a second. It looks like our border is coming through, so let's try replacing this with, rather than a border, let's just use an overlay instead. And with this overlay, we'll fill just like we did before, and we'll put in a padding of 500. There we go. That's what we want. And we'll do 500, not on the bottom. That's going to be weird. We'll do 500 on the right. Okay, so that's good. And then we should probably replace this border just in case with an overlay as well. And we're going to have to, once again, with this, we'll go ahead and fill so that it all lines up properly. Okay, so what that should do is that should anchor. You can see as I resize my window now, it all scales appropriately, which is kind of what I was trying to get to. So now we have our health bar. We need to do a little bit. We're going to call this, let's rename this. This is going to be our progress bar health, hero health, for example. Or we could just call it health. And it is a variable. That's good. And let's go ahead and change our progress. So left to right, we're going to go halfway. So this blue is our health. We want to reset this to a nice bright green, just for clarity. And then we would like to reset our background. Somewhere in here is the background color. Border padding, fill color and opacity. Let's see if we can just type it in. Maybe it is actually white. Let's see if we change this. Yep, that's it. That was tricky. Okay, so I think that's a pretty harsh red. So I'm gonna go for something like this. Okay, so now we have our health bar. We have our scoreboard. We just need to connect them up. Now, interestingly enough, our scoreboard no longer has the padding from the corners. So let's offset 50. Let's do, is that what I want, or do I want to do it with the padding? I'm going to do it with the padding. Let's go back and change this offset to 0. Let's change the padding on our text to be 50. Yeah, there we go. I don't know how we lost our padding, maybe when we swapped our boxes, but there we go. Let's compile and save this. And then what we need to do is we need to do the same type of thing that we did before, where on basically on our what we want to do is we want to get the player, and then, or no, we want to get the game mode. So let's do this. Let's get the game mode. Get the game mode. Get the game mode. So here's our game mode on construct. And what I'm going to do is I'm going to promote this to a variable just so we have it. I'm going to name this the game mode. And now that we have our game mode, we can use this to kind of set up all of our values by creating a bunch of bindings. So let's go ahead and do that. We may have been able to do that even without getting that, but I like to have it for later just in case. So back in our designer, for this text, for the score, what we are going to do is we're going to click on this bind button and see if in our game mode only has an option string. So let's just create a binding here. So let's get the game mode, get game mode, and from there, let's get our score. Maybe we don't have a score in our game mode yet. Let's go back. Projectile base, blueprints. Here's our top-down game mode. And let's see here. We do have a score. But we forgot to cast it. So let's go back to our widget. And what we're going to do is we're going to change this game mode to be a TSS game mode. But we didn't call it that. It's actually top-down game mode. So let's just change this to a top-down game mode. change the variable type. That's going to mess up a little bit in our construct, so we're going to have to go back to that. And we're going to, because it's not going to be able to do this. If we try to plug this in, you see how it doesn't work. So we need to cast this. We need to cast this to a top down. And once again, reminder, casting, all it's doing is saying, is this game mode a top down? And if it is, continue and give me access to all its stuff. So let's just do that. We'll compile it again. And just out of curiosity, if we go back to our designer, do we have any more than we had before in our bindings? Oh yeah, we do. We don't even need to do this. Okay, so let's remove our binding. So by creating our game mode properly, by casting it to the right type, when we click on bind now under game mode, it's kind of off screen. I can show you, actually, if I just resize this a little bit, just so you can see what I'm seeing. If we click on the bind button here, you'll notice that now our game mode has a score option. So we can just bind it straight to the score option. By doing that, when we run our game, we don't even have to do any of the work to set up getting the variables and doing all those things manually. We can just go ahead and use that. That's great. Now, for our health bar, this one is a little bit different. We need to get our player. For us to get the health, we need to get our player and we need to get their health component. So let's go ahead and do that. So let's get our player, get the player. And we are going to take the player and we are going to cast this to, I believe our players are top-down characters, which is great. And if this is successful, we're going to get the health component, And with that, what I want to do is I want to, let's go ahead and promote this to a variable. And the reason we're doing this is, we'll call this player, let's call this component player health. The reason we're doing this is so that we don't have to recall it, etc. Let's compile this. Let's go back to our get score. We don't actually need this anymore. And let's go back to our designer is what I meant to say. And then down here for our health bar, for our progress, we are going to create a binding for this one, because remember we have to do a little bit of math. So in here, for the progress bar, we are going to create a binding by clicking on create binding. And then remember, we want to do this in the proper order this time. So let's get our player health component. Let's get the current health. Get the health. That's our current health. Let's get our max health. And then we're going to divide the current health by the max health. So if our current health is 100, max is 100, this is going to be 1. If our current health is 50 and our max is 100, we're going to get 0.5. So that's going to create that binding. Okay, so our widget is ready. Now all we need to do is we need to tell our HUD to spawn this widget. So in begin play, what we're going to do is we are going to create a widget, I believe. Yep. And the widget that we're going to create is our new HUD widget. So let's just type HUD in here. It's a TSS HUD, and we should be able to just simply add this to the viewport. Now when we do this, we're almost there. If you've gone through our horde mode tutorial, you know that what we need to do now is we need to actually change our default HUD for our game mode. So if you're looking at your map, you need to make sure you have your world settings window. Your world settings window is over here. If I just pop this up here, if we take a look at the options, there's our game mode override. And in our selected game mode, you can see we have the HUD. So there's two potential ways to do this. What we could do is we could go and we could take a look at our game mode and we could change the HUD right here. So if we just change this to HUD TSS, compile and save that, when we go back, you'll notice that this now defaults to HUD TSS. Or if we potentially have different ones, we could just overwrite it in the world settings here. Okay, so now when we play, do we have a HUD and does it work? We do not have a HUD. Oh wait, we do. We have a score in the top right, but interestingly enough, we do not have a progress bar at the bottom. So we got to figure out what's going on with our progress bar. So let's do a couple things with this. We know it's here, but it looks like it's potentially off screen. So let's take this overlay and let's get rid of, let's check our alignment. Okay, there we go. So that's maybe our alignment was pushing us off screen. And I'm also going to change the padding to be maybe 50 at the bottom. Oh no, we don't want that. Let's see here, our overlay, offset right and left. First, let's just see if we see it. Was that our actual problem? Yeah. Okay, so we have a giant health bar now, which is great. Oh, our giant health bar is hurting. Okay, so that actually did it. We may want to, right now we're doing this as percentages. We could specify a specific size, whatever it is we want to do. But the overall bottom line is we have our health bar. Now I might put some kind of padding below this, as I mentioned. We have our position, we have our anchors. Let's see here. We could do this pretty simply. You know what? Let's wrap this. We're going to go ahead and right click and we're going to wrap this with a vertical box. A vertical box, every element you put in it stacks on top of the next one. Was in our overlay. We can set the size to, let's say, 60, for example. That's going to make it twice as tall. And then on our health, what we can do is rather than filling vertically, we can align to the top. All right, so now that we've aligned it to the top, we should be able to pad the bottom. Let's pad the bottom with 40, 30. That's good. Okay, so that should give us our health bar a little bit off the bottom. There we go. That feels a little better. Now, obviously, you can go ahead and set up your health bar however you want. That doesn't get in the way. It's rightfully big, and it's pretty apparent that I'm going to be hurting here in a second. All right, so we're in a really good place with our UI. We got our health bar, we got our scoreboard. Now what we need is we need a win screen. We need victory, defeat, pause, restart, resume, all the good buttons. Now we could probably give this a shot as just part of our current HUD. So maybe what we do is we create another overlay, for example, or actually probably let's just do a vertical box. So let's do vertical box. Let's drop that inside of our canvas. And inside of this vertical box, we're going to add in text. The text is going to be, in this case, let's set this to victory. And we are going to make it a lot larger. So let's do something like that, for example. And I want to take my vertical box and I want to anchor it right in the middle of the screen, I think. So to do that, we're going to go to our anchors. We'll go middle. We'll reset all of our offsets. And then we need to change okay, so here's what we need to do. We need to change our size. So if we go size to content, and then we go 0.5 and 0.5, that will get our victory right in the middle of the screen. Whew, UI stuff is fun. Okay, so we have our victory. Now, I want to be able to change this text. So there's a couple different ways. I could have different text, or I could change what's in the text. I'm going to go with different texts. In order to do that, what I'm going to do is I'm going to wrap this with an overlay. So let's do this. I believe it's an overlay that I want. And the reason being is if I duplicate this, I want a defeat, and one more for, let's just go, sure, we can add pause. Let's go ahead and add pause as well. And let's make pause a nice blue color. And let's make defeat a nice red color. And let's make victory green. Okay, so what we want to do when we first start, not our game mode, in this HUD, let's go ahead and we can get rid of this here. So on our pre-construct, for example, we got to make sure all these are variables actually. None of them are variables. And just to keep them straight, let's label them text victory up here in the top right. Let's check the box for it's a variable because we need to be able to set these. It's going to be a text defeat. make sure it's a variable, and text pause. And is variable. And we're not going to handle pause quite yet, but let's just start with these two. And then in our graph, back to our graph, let's go ahead and take our text pause and set the visibility. And we're going to set it to hidden. So we're going to do that for all of these. Text defeat, hidden. And fortunately we can connect more than one thing to this same pen, so it just helps keep our graph clean. Text victory. Okay, so when we compile that, when we go back to designer, we shouldn't even see them here. They're hidden. They're hidden because by default, that's the way it is. And what we can do is in our game mode, what we can do here is spawner count goes to 0. Rather than printing the string you win, what we can do is we can tell the HUD that they have we can basically tell it to pop up the win condition screen. And to do that, what we need to do is we need to get our HUD. So this is our top-down game mode. Can we get our HUD from here? Get the HUD. Get the HUD class. That's the class. So let's get the control. Get the player controller, and with that, let's get the HUD. Can we get the HUD from this? Yes, we can. So here's our HUD, and what we're going to do is we're going to cast this to a TSS HUD, and with that, we are going to, with the HUD TSS, we are going to, oh, interesting. We're probably gonna have to store a variable for this widget because it's stored there. Every time we've done this in the past, what we did is the HUD was a separate class, or the win screen was just a separate screen that we popped up. But because it's part of the HUD, we need to do a little more work. Okay, we can do that. So rather than just adding it to the viewport, let's promote this to a variable. That way we have access to our HUD later. And this is going to be our HUD. This is going to be our TSS HUD. Okay, and then what we want to be able to do is let's add an event in here. Let's do a custom event. And the event that we're going to add is event victory. And for that, we are going to get our HUD, and we are going to, off of here, we're going to say show victory. So in our HUD, we need an event to show victory. So let's come over here and get rid of this tick. We're going to add a custom event here as well. And it's going to be event show or handle victory, whatever you want to do. Show victory, for example. This is going to be very straightforward. We're just going to set the visibility of the victory text, and we're just going to set it to visible. And then while we're here, since we know we're going to have to do this to the others, let's just go ahead and show defeat, because that is going to be easier to test because we get just destroyed by our enemies so fast. So event defeat, and let's set our visibility to visible, and it's the defeat text. There we go. Okay, cool. So we got that. Now what we also want to do is, so now that we have those, we need to go back to, where were we? We were in the HUD. So on victory, we need to take, I'm going to compile and save this, by the way. We need to take our TSS HUD and call victory. So that's our event show victory, which is cool. And then let's go ahead and create an event, add another custom event. And this custom event is going to be event defeat. And once again, we're going to get our TSS HUD, and then we're going to do a defeat. So now our HUD container knows how to send the message to the actual widget that is the HUD. And then all we need to do is in our game mode with this HUD, we can just go ahead and, what were we doing here? Oh, this is our victory. So let's do victory. And this should create a victory for us. So let's see if we can test that real quick. We got to kill all 4. Oh my goodness. Let's try defeat first. Let's see when our defeat is done on our player. So let's go to our blueprints, top down character, and where do we ragdoll? Begin, do affect health. Affect health comes in, spawns a system, destroys the actor. If it's a player, we disable input, we set collision enable, we set simulate physics. So the other thing that we want to do here is do we have the controller already? We do, we have the player controller. So let's get the player controller, get the HUD. And we'll just go ahead and cast this to a TSS HUD. And from that, let's just do show defeat. Let's see if that works. That's going to be easy to test. Defeat. Here's a defeat. Okay, so theoretically, in addition to getting ragdolled, now we're going to go ahead and try to win if we can, but if we end up losing, it'll be all right. There's defeat. Okay, so our HUD is working, which is great. So we just need a couple more things that we want to add to that. Let's see here. How many characters are these spawning? These are each spawning under our details 1. Man, I am getting wrecked with 1 enemy. So let's try setting these to 0 for a second, just to see if we can just double check that our victory works. And go. So this is the only one that should spawn, although we have never tested the 0 condition on our spawners. Victory. Okay, so both victory and defeat work. Perfect. Okay, so now we have our victory or defeat. We need a couple buttons. So let's go back to our UI. We have this nice overlay. Let's go ahead and drop in a button onto our overlay. This button, not a border, a button. Button. This button is going to be called button restart, for example. We're going to make it a variable, yes please. And for now, let's just go ahead and fill that. Now, interesting. It's because I parented it to the overlay. I don't want it in the overlay, I want it in the vertical box. And the reason I want it in the vertical box is I want to I'm going to need a couple buttons. But just to help us keep them straight, let's drop some text on this restart button. And we are going to label this when we pick our text as restart. And I'm going to make my button a little bit darker because it'll be easier on the, oh, that's the text. I want the style, normal, and under tint, let's just go ahead and drop. Let's just drop this down so it's a little easier in the eyes. There we go. And then let's do some padding. Let's say on the left 50, or is that 80? That's 80. We'll go 50. Yeah, let's do 100 and 100. Okay, so we got a little bit of padding, and now we have a restart button. Now I'm just going to duplicate this. I'm going to call this button restart, and then we have button quit. And let's go ahead and change the label on quit. So we have restart and quit, and I do want a little bit of padding in here. Let's say 20 between the buttons, that's good. And let's duplicate this one more time, and we're going to call this resume. That would be if we paused our game. Wow, this tutorial is going to be beastly. There's so much in here. So this would really only be if we pause our game. We're going to have to do some switching of hotkeys to do that reasonably. So let's go ahead and do resume. Okay, so we have our button for restart, resume, and pause. Let's put some padding at the top of, I believe we did 20. Okay, we're gonna double that. I don't want to accidentally click one versus the other, so. And we'll even put some padding here, so there's some padding between the top. So we have resume, restart, resume, and quit. Now here's the problem. When we start this, these are all going to show up on our screen when we press play. We don't want these to show unless some conditions are met. The conditions are met would be we pause the game, we have a defeat, or we have a victory. So let's go ahead and take each of these and hide them as part of our construct. So we're going to take each of these 3 buttons and we'll hide it. We can just feed it straight in. This is great. That's button quit. Let's get our button restart. And finally our button pause. Quit, resume. Okay, so now everything should be hidden, which is great. And then what we want to do is when we do victory, we want to show our buttons now. So as part of that, we can basically take, well actually we can just copy all of these. We want all 3, I think. Actually, for a victory screen, we don't need resume. We need restart, quit, and there we go, resume. Now, we would potentially change this slightly in the sense that, like, if, for example, victory, there's a difference between victory and beating the current level we're on. We would just have to change the functionality a little bit if we were to go to another room, for example, to beat the whole dungeon, as an example. All right, for the defeat screen, what we want is we want quit and restart. We don't need resume. So let's just take those, connect those in, and now let's just see if we can test these. So first things first, let's get rid of our spawners before anybody comes. It was a little slow. All right, so we're gonna test victory first. Victory. So we have restart and quit. So now what we need to do is we need to connect these. So in order to do that, well, let's just go ahead and double check our defeat first. Where's our enemies? Here comes one. Defeat. Oh man, he wrecked me. So we have restart and quit, which is perfect. Okay, so what we want to do in our widget is we're going to go ahead and for our button quit, let's add onClicked. Okay, and after we add our onClicked, this is actually pretty straightforward. I believe we can just call quit game, which is great. So we don't have to do anything specific. We don't need a specific player or anything like that. And what we can do is we can go ahead and press play, and then we can either try to win or we can see which happens first. We get that spawner. Here's our victory. It's ours. And can we quit? Yep, that pops us out. Okay, so very quickly we have a quit. Restart is a little bit different. What we're going to do with our restart is in our game mode, we're going to create an event here. So let's add a custom event. And this is going to be event restart. And what I want to do in here is I want to basically, I believe it's open level by name. And let's see, can we get level? Get the current level name. There we go. So all we do in order to restart is we just basically reopen the level. Now, there's 2 different ways to restart. We actually covered both in the mob dash. One is you basically open level by name. The other one is you execute a console command, which is basically, I believe it's restart level. So in here, I think if we just connect this up, what we can do is now we just need to call event restart when, yes, we need to call event restart from our, and this is resystart. So let's just change this restart. We need to call that from our HUD when we click on restart. So over here on the left on click, what we need is we need our game mode. We do not have that. So this is currently our HUD. Our HUD does or does not have the game mode. It does not. So let's go back into the HUD for our widget. Let's get on begin play. Let's get the game mode. Oh wait, we do have the game mode and we set it. Did I just miss it? Oh wow, it's just, okay, it was just hidden down there. Okay, so we do have our game mode. We don't even need to do that. So for restart, we're going to get our game mode, and then we're going to call restart. Because this game mode is a top-down game mode, and that event is specific to that one, we should just be able to call restart. Now what this should theoretically do is, whether we do victory or defeat, we should be able to just go ahead and click restart and restart the match. So let's go ahead and do that. Okay, so if we restart, there we go. That's it. So just like that, we have a restart, a quit, and we do not have a pause yet. Pause is a little bit different. So I don't mind that our character can run around during our victory or defeat screens. Pause, we need to do, basically what we want to do is, in order to pause our game, we're going to have to do a new keyboard binding. So to do that, we're going to need a new input action. This is all part of UI stuff. It's kind of fun, right? All right, so let's just go ahead and create a new input action. This is going to be our input action pause. And what we can do is, in here, it's digital bool, that's fine. Let's save that. Let's go back to our input. And what we want to do is, in our input mappings, we need to go ahead and add in one for pause. So here's pause. Now, in order for pause to work, what we need to do is we need to give it a key. Now, a lot of times what I see happen is we swap the escape key to basically be the pause, because that's what people think of. But for now, just for ease of implementation, we'll just go ahead and put it on the P key. Okay, and with that, now we can pause our game with the P key. If we press escape, the problem is escape by default in the editor is end the experience, quit the game. What we would probably need to do is change it to shift escape and then add escape as a thing. Although, you know what, we'll try something in a second. For now, let's just get this working with the P key. All right, so that's our input. And then what we need to do on our top-down character, here's our top-down character. Oh, remember, all this stuff's on the controller. So let's go back to our controller for our inputs. Here's our top-down controller. And what we're going to do in here is we're going to add in a pause. Here's our IA pause. Nope, that's not what I wanted. I want our event pause. Enhanced input action. Here we go. When this is triggered, all we need to do is we need to get from our variables. We do not have the game mode. So let's see here. Let's see if we can do all of this without the game mode. So when this gets triggered, what we're going to do is we're going to disable input. And no, we need, well, this is the player controller. Self. Okay, and then let's see if we can also, we also want to pause the game. Can we pause the game here? Pause game. Set game pause. We can do that without getting the other stuff. So first thing we're going to do is we're going to pause the game. Then we're going to disable input, so nothing's happening. So that should take care of that. I was actually thinking we need the game mode, but we should just be able to get the HUD and tell the HUD to tell the game mode what to do. So let's try that. So let's get the HUD. And let's cast this HUD to a TSS HUD. And with the TSS HUD, what we want to do is we have event victory, event defeat. We need to do let's add an event, a custom event for event. And I'm going to be explicit with show pause. The reason I'm doing that is because unlike victory and defeat, we need to be able to, we're not actually changing the game state, okay? So here's what we're going to do. In this case, we need an event for show pause. Yep, so let's just add it. So right here, let's just add a custom event. And it's going to be event show pause. and we are going to take and we're going to set the visibility on our restart. Actually, we're going to set visibility on all of them in this case. So we're going to set restart, quit, and pause. Let's see here, pause, and resume. That's the one we're missing. Okay, so down here, here's pause. So we have resume and pause. So we can do all the things when we're doing the pause. Okay, so let's compile that. Let's go back to our HUD. And when we do this, we are going to get our HUD and we are going to show the pause, which is good. Okay, and then if we go back one more, I'm using Control Tab, by the way, to switch back and forth. With our HUD, we should just be able to show pause. Okay, so whenever we press the P key, we should be able to do a pause now. So there's P, we're paused. Now, I can't move, I can't do anything. The cool thing about the top-down shooter, if you remember, or if you did the Mob Dash mini game, we had to do a lot of work to still show the cursor and a lot of other things. But because the top-down shooter has a cursor visible already, we don't have to do any of that. So let's test resume. It does nothing, but quit works still, which is great. So let's go ahead and actually, let's just go ahead and test our restart from here. Okay, so restart works as well. So we actually just need to connect our pause now. So let's go back to this widget, and what it is our button for pause, which is resume. I don't know why I did that. So our button for resume, because I know why, because I didn't want to call it unpause. Over here on the left, we're going to add our on-click event. Now, this one, we do need to do a little bit more work, because back here in the controller, we set the game mode to pause and we disabled the input. We need to re-enable the input, and we need to set the game to pause, and we need to hide all of the widgets that are as part of our HUD that we don't want to see when the game is actually being played. So let's start by setting the visibility on all of these back to hidden. Okay, so these are all going to get hidden. So now our UI should disappear. Let's set our pause, set our game mode to not paused, so basically unpaused, which is great. And then we should probably, let's re-enable our input before we unset the pause, just in case. So to do that, we do need to get our player controller. Do we have them anywhere? We'll just get, let's just try to get player controller. Or can we disable input? No, we need the player controller. So let's get the player controller, and let's enable input, and then the player controller, that's the actor. Okay, so that should be our pawn. So we're going to do this. So let's also get our controlled pawn. Get player pawn. Okay, so we'll put the player pawn in here just in case. So we're covering all of our bases, and we should be able to resume. Okay, we are almost there with UI. All right, so if we press pause and we go to resume, we didn't get it right. And in fact, we did get it right from the standpoint that the enemies still spawn, the game is going, but our inputs are not actually getting re-enabled. So let's see what we missed here. If we go back to our top-down controller, we disabled input on our top-down controller. So we didn't feed the pawn into this one here, so let's see if that's our problem. So we'll just basically try testing that by going ahead and reconnecting that like so. We'll go ahead and press P for pause. For pause, we can't move, we'll resume, and now we can move again. That's all it was. So we basically disabled input on the controller, and we needed to re-enable that. All right, we got our UI. Our game is actually really shaping up. I know this is a beast of a tutorial, but I kind of think we need a weapon. Here's why. Right now, our character is able to shoot projectiles, but it's not really associated with the idea of a weapon. And any twin stick shooter probably has more than one weapon. So it'd be really cool if we took this as an opportunity to show you how we might implement a couple different weapons. Now, before we just hop in and start building stuff, let me explain to you what we're going to do. We are going to build a weapon blueprint. That blueprint is going to be something that the character can use and activate to shoot. So we're going to need a weapon blueprint. We're also going to have to move all of the projectile work that we did in the character into the weapon so that the individual weapons can control how they shoot or not. So we're going to be doing some work there. And then we also are going to be adding the idea of some kind of gate or limiter like attack speed. So let's hop in and get started on that part of this. So what I'm going to do is I'm going to create a new folder here. I'm going to call this weapons. And inside our weapons folder, we're going to need a new blueprint. And this is just going to be an actor. And this is going to be blueprint weapon base. And since we crashed, we're also going to fix this real quick so you can read this better. Okay, so now that we have our weapon base, what we want to do is in here, let me dock this. We basically, in our event graph, we need to set it up so that we can activate our weapon. So we don't, for right now, I'm not going to worry about begin play or overlap or anything. I'll just go ahead and delete those. And let's just say, add a new event, add custom event, and this is going to be event trigger weapon, for example. You can call it fire weapon, attack, whatever you want to call it. And what we want to do in here is we want to do everything that we were doing in the character to shoot the projectile. So we need our character. So let's go to our character, and we were doing that in the top-down controller, I believe. Where's our attack? Here's our primary attack. Okay. Now what we want to do is we basically want to do all of this, but inside of our weapon instead. So let's go ahead and grab that and I'll paste it in here. And we're effectively going to spawn a projectile. However, we do have a couple of things to potentially look at. This will still work because we're getting the control pawn here is actually slightly different. And what I mean by that is in the character, in the controller, when we get the control pawn, it's getting us the actual pawn. And so we can use that to get the facing so we know which way to shoot our projectiles. But the weapon is going to get attached to the character. And if it's attached to the hand or anything like that, it may not know where it's attached to. So what we are actually going to do is we're going to delete this first off. And what we need to do in our weapon is we need to have some idea of the weapon owner. So let's add in a reference. Let's create a variable for that, for weapon owner. And the reason I want to do that, and what we're going to do is we're going to set this to type. This type is going to be top-down character. And then what we are going to do, rather than getting the control pawn, we're just going to get our weapon owner. And with our weapon owner, we're going to get our actor transform, and we're going to set this as the instigator, and we're also going to set it as the owner of this projectile that we're shooting. Okay, so we've theoretically set it up so that when we trigger our weapon, it will get whoever the owner is of the weapon, and it will use all of the same stuff to figure out which way our facing is. But we do need to now equip this weapon. So let's go back to our controller. And let's add a variable to our controller. This is going to be our primary weapon. And I'm calling it primary because with this knowledge, you can later on go on to make secondary or whatever else you want. Let's call this a weapon base. And so that is our weapon base reference. Now we need to set this. So here's what we're going to do. Right now, we've done nothing to actually equip the weapon. So let's go ahead and create an event for equipping our weapon. So I'm going to add an event. It's going to be a custom event. This is going to be event equip weapon. And what I want to do when we equip the weapon is I want to get our primary weapon. I want to see if it's valid already. Is valid. And the reason I want to do this is what is going to happen later is if we pick up a weapon but we already have one, what do we do with the one that we already have? We're going to destroy it. So if we have a primary weapon and it's valid, what we're going to do is we are going to destroy this actor. Destroy that. Pretty straightforward. Then what we're going to do after, I'll just move these up here because a lot of the bulk of what we're going to be doing is down here, is if we don't have a primary weapon, we need to spawn one. So if it's not valid, we are going to spawn actor from class. Spawn actor from class. The actor that we're going to spawn in this case is not an enemy, a weapon. And then what we want to do with this actor is we want to attach it, attach actor to component. Now we could attach actor to actor, actor to component, whatever you want. I'm specifically choosing the component because what I want to do is I actually want to get the skeletal mesh and I want to put it in the right hand, for example, if you have a visual. So the parent is going to be the controlled pawn. So in this case, we have our controllers get the controlled pawn. We may change the way we do this here in a second. Here we go, get our controlled pawn. Can we get the mesh from this? Okay, we can't get the mesh from this. So what we're going to do instead, what we can do instead is we could do a cast, for example. That's interesting. Or we could do our equipping on the pawn itself. It's kind of weird that we're doing this on the controller. No, because we may want to change our type. Okay, so let's go ahead and do the cast. What does that mean? It means that what we need to do is we need to get the controlled pawn. So as we just did, if we get the controlled pawn, we have no concept of what this is right now. Okay, so what we need to do is we need to check to make sure it is a top-down character. And the reason that we're doing that is because when we have a top-down character, we can get the mesh. And with the mesh, we can then attach it to the right hand, left hand, whatever you want to attach it to. Now, here's the thing. Do I want to do this every time I equip a weapon? Or when this starts, do I want to store the controlled pawn, for example, as a variable I can reference later? We could do either one. Let's see what we have in our begin play right now. Yeah, let's do this in our begin play. That way we have a variable. Okay, so so the logic of why we're doing this at begin play is because we don't want to do this every time we equip and unequip, even though it's not that expensive. So here's what we'll do. On begin play, we're going to get the controlled pawn, and I'm going to explain to you a little bit of thing to watch out for. I'm going to promote this to a variable. Get rid of our mesh for right now. And so what's going to happen is it is going to set this, and we're going to, rather than calling this as BP, I'm just going to call this controlled pawn. Okay, so now this is available to us to use all the time. I want to caution the example I used where if for some reason you swap out your pawn, you will need to update this. Okay, but we're not going to worry about that for now. But what we do now have is we have a variable we can use. And so what we're going to do is we're going to take our controlled pawn, we're going to get the mesh, and we are going to fill that into the parent. And then I'm going to attach whatever it is to hand right, for example. And we can do snap to target, snap to target for both location, etc. What that would do is if we had a visual, it would snap it in place, so it's in the character's hand. And maybe we'll just add one for demo purposes here in a second, but for right now we just need to get our weapon base spawned and attached to our character. The other thing that we want to do when we spawn this weapon base is we want to set it as our primary weapon. All right, this is all in our equipping of the weapon. So we've assumed at this point that if we had a primary weapon, we destroyed it. If we don't, we're going to spawn one, and we want to set our primary weapon. So let's go ahead and do that as part of this section. And now we have a primary weapon that has now been attached. Now, the other thing that we need to do though is after we destroy the weapon that is already in place, we do need to go ahead and continue to spawn the new one. Now, eventually we're going to need to make this a variable, the type of weapon, so that we can choose what kind of weapon we are going to equip. But for now, we're just trying to get everything set up so that we can actually trigger our fire. So let's see here. Oh, we need to transform. So let's make a transform and connect this in. So we do need to have a default transform for this, even though we're going to be doing the snapping here. All right, so let's compile that. Let's save that. And now that we have our weapon, we need to be able to trigger the weapon. So what we're going to do is let's take our primary attack, and then all we're going to do is in our primary weapon, we are going to trigger the weapon. Now, one thing that might be worth checking is whether or not our primary weapon is valid here. And the reason for that is if it's not, we don't want to be trying to trigger an invalid weapon. So theoretically, we've gotten rid of all of our old way of doing this, and now when we begin play, our character should have a weapon and we should be able to shoot. So let's see where we're at. Okay, right now we missed something, so let's take a look. We have our primary attack. We check to see if our primary weapon is valid. It may not be valid because it's possible that our equipment is not getting equipped. Oh, we're setting our control pawn, but we haven't actually equipped the weapon yet. That's all it is. So let's go ahead and equip. Also as part of begin play, equip our weapon. Now this is just going to equip our default weapon for now, and we can try that again. Okay. So it is trying to fire our weapon. Here's our equipped weapon. It does all of the work, and it comes through here. It attaches it to the right hand. There we go. Now let's take a look at our weapon base. I want to know if we're actually doing this. So let's print, I know what's going on. Let's print the string. We should see this hello. When we trigger, you can see it printing hello on the top left. However, it's not actually spawning our projectiles. Why not? The reason is right now we don't have a weapon owner. Our projectiles are being spawned somewhere off in the middle of nowhere. So what we want to do is when we spawn this a weapon, we want to assign our weapon owner. We want to tell it who the owner is. So in order to do that, we need to make it instance editable and expose on spawn. So compile and save that, and then we got to go back to our top-down controller. And when we equip this weapon, when we spawn this weapon base, if I right-click here and refresh this, you'll see there's now a weapon owner option here. I want the weapon owner to be the controlled pawn. Okay, step by step, so you all can follow. All right, so now that we've got that, we can now actually shoot again. Now that means that we can get rid of our hellos. We don't need those anymore. And we still have our victory conditions, which is great. So we've successfully converted our weapon, or not our weapon, we've successfully converted our attack to a weapon-based attack, which means now we can create additional weapons. So let's go ahead and let's make a new weapon. Let's make a split shot. And then I'm going to show you all how to pick up different weapons and swap them out. So let's take a look at that. So to create our second weapon, what we're going to do is we're going to leverage our first weapon. And the way we're going to do that is we're going to use something called inheritance. Now, I'm going to introduce you all throughout this tutorial to a couple even of the more advanced topics like inheritance and blueprint interfaces and things like that. I'm going to explain them hopefully in a way that you will understand. You may not have wrapped your head around them, but at least you will have had an introduction, because the goal is to try to teach you how to do these things the right way. So what we're going to do is we are going to go ahead and right click on this, and we're going to create a child blueprint. This is going to be blueprint underscore split shot. Let's call this split shot. And let's have a chat, not split shot. Let's have a chat about how this parent-child relationship works. So split shot is the exact same thing right now as weapon base. It does all of the same stuff. It shoots, it has an owner, it has all those things. However, we have the ability to override things. So let me show you in practice what I'm talking about. Right now we're spawning weapon base. If I change this to split shot, what I want to show you is when we play our game, we can still shoot. Okay? If I go back to weapon base, I can get rid of the hello. Even though I'm changing weapon base, I'm not changing split shot. Compile and save. And when I press play, you'll notice that I'm not printing hello. It is doing exactly what weapon base does. So what do I mean by when I say I can override it? Well, what I can do is, because our parent basically is inherited down in the child. The child can do everything the parent can. It understands everything that the parent has. It has all the same events, etc. But the parent cannot do everything the child does. So if we change the child, the parent won't know about it. So let me show you a good example of how that works. So what I want to show you here is in our functions, let's do trigger. I'm going to call trigger. So you'll notice that we have this event trigger weapon. No, I don't want to call it. Add event trigger. Add event trigger weapon. Okay, so if I just add this event and I do a print here, what's going to happen is when I press the trigger button, it is going to print hello. But I want you to also note what else happens. I'm pressing the button, it's printing hello on the top left, but look, there's no projectiles. There are no projectiles because the child, this child add or event trigger weapon is basically the overriding what the parent had going on in the event trigger weapon. So what I want to do is I want to change this. I want my child to do the same thing the parent does. And to do that, we do something called add call to parent function. So now if I leave this, if I just go ahead and if I play right now, it won't print and it won't shoot. If I simply connect in this add call to parent, what this means is here's the child trigger weapon. I want to do whatever the parent's doing and then I want to continue on. So I'm going to print a string here for child. So here's what's going to happen now. Even though we don't have a print in the main weapon, we do have one in the child. So as long as it's a child, you'll see it's printing child in the top left. That's because what's happening is we're doing what the parent said to do, plus we're doing whatever's in the child. So here's what we're going to do in this child blueprint. We're going to create a split shot. So we have, let's copy all of this information. We're just going to copy these, and I'm going to take this and I'm going to paste this in split shot. The reason I'm doing this is because I want the projectile from the parent and then I want two more, one on each side. So I need two more projectiles. Now the rotations of this projectile are going to be a little bit different. So let's break this connection and split this. And then what I want to do is I want to take the rotations here and get the forward vector. So what this does is this gets which way our character is facing. And then I want to take that and I want to rotate it 10 degrees to the right, for example. So what I'm going to do is I'm going to take this vector and I'm going to rotate it. I'm going to rotate vector and it gives me an angle that I can type in. So let's do 25 degrees. Here's 25 degrees. And then what we'll do is we are going to split this pin struct here and we will go ahead and connect in all of the stuff. So our position is going to be the same. Our rotation is going to be this new rotation of a 25 degrees. And we'll see if we got the axis right here in a second. And we can leave our scale as 1. For now, I'm going to skip the call to the parent and I want to just see the 25 degree offset. Okay, it's not super pronounced, but it's there. We have a 25 degree offset in our projectile. So that's working. Now, if we add back in the parent, which shoots a projectile straight ahead, we should have our parent projectile plus our child projectile, but we may not, and I'll explain why in a second. We don't. Why not? Let me show you what's happening. So if we come back in here when we spawn our projectile, if we come into our projectile, what I want to show you is when our projectile begins an overlap, it checks to see if the other, if it's overlapping its instigator, and if not, it goes on and it continues to do the work. Now, the problem is both projectiles are spawning in the exact same position. So they're already on top of each other, so they're already hitting each other, so they're destroying each other. And we can see that because if we put a print string here, we know that it's coming in here. You can see it prints hello. So we know it's getting there. And that is exactly what's happening. So we have a couple of options here. One, we could change our collision presets for our projectile to only overlap pawns. So let's try that one. So let's overlap only pawn. Let's compile that and save it, and then go ahead and try. So now we have our double split shot projectile. It's pretty cool. And the reason that's working is because, as I said, we are no longer colliding with our own projectiles. Now, the other thing that we could do instead of overlapping only pawn is we could also test to see if we're hitting another projectile. But this really gets into how you design your own experience. Do you want bullets and projectiles to be able to hit each other or not? Those kinds of things, and you can set that up. So that was a quick little explanation of what's happening there, but let's get back to our split shot. So we already have one shot. Now let's do the same thing, but this time let's rotate the vector again. Rotate the vector. And this time, rather than positive 25, let's go negative 25. And we are going to do the exact same thing. We're going to spawn a second projectile in here. So we're going to come into the first one, and we could probably use a sequence. I pressed S and left clicked right there. That creates a sequence. The way a sequence works is it basically goes in sequence. It does the items in the first slot. When it's done, it comes back and does the items in the second slot. Okay, so we are going to take these values and we are going to connect them into both projectiles. That's our spawn transform. This is our rotation. We can leave our scales. So at this point, we have created a split shot, and our split shot takes what our parent is doing, which is shooting a single projectile, and then it adds two more on either side at a 25-degree angle. So let's see what that looks like. Defeat. Oh, we are accidentally, okay, what happened there? We accidentally destroyed ourselves. That's because we did not connect in the weapon owner. Remember, our projectiles are set to ignore the weapon owner. We need to connect these in. Otherwise, we basically just shot ourselves in the stomach. So here we go. Let's try that again. Okay, so now we have our triple shot. Now, this is a very wide triple shot for me. I don't actually like this angle from a twin stick shooter standpoint. So what I'm going to do is I'm going to change that to be a little bit less. Let's try 5 degrees. Let's see if that feels better. That's pretty good. It's pretty powerful. Actually, it's ridiculously powerful. Victory. We're so good at our own game. Okay, so that's going along pretty well. Let's try a little bit more, maybe 7 degrees on each side, and then we'll call this done. 7. Compile and save. Okay, I think that feels pretty good, which is great. Okay, so now that we have two weapons, what we need is the ability to pick up the weapons. So what we're going to do is we're going to create a pickup and the ability to equip each of those weapons to our hero characters. So let's go ahead and do that we're going to be using a combination of blueprints and blueprint interfaces, kind of like we did with the health pack. So let's hop in and take a look at that. Okay, so in order to be able to pick up weapons, we need a weapon pickup. So let's go to our blueprints and let's go ahead and create a new blueprint class. This is going to be an actor. This is going to be our blueprint, and I'm going to call this a nice generic item pickup. The reason we're doing that is because we're future thinking. Right now we have weapons, but maybe you want to be able to pick up power-ups or whatever else in the future. You can always change this later. So in our weapon pickup, what we need to do is we need to be able to walk over a thing and get whatever the new item is that it wants to give us. So in this particular case, let's add a visual piece. Let's make that a cube, or cube. This is going to be the pad that we can step on, and I'll go ahead and shrink that down. And I'm going to add this to my map just so I can check the sizing real quick. That's reasonable, 1 meter by 1 meter. Okay, so now that we have our pad, we also need, in our scene root, let's go ahead and add a collision. This is going to be our box collision. Okay, and we just need to size our box collision to match our pad. And basically all we're going to do is when the character walks on top of this and it collides with this box, it is going to trigger the pad to give us the weapon. So here we go. Let's do a couple things. First off, let's change this cube. I'm going to disable all of the collision. I want my character to be able to walk right through the thing. I think ultimately my damage or my item pickup pads would be like some kind of cool mystical effect or something like that, for example. So no collision at all. You can't walk up on it. All that's great. The box though, we do want collision. And what we could do is we could just do overlap only pawn, which is cool. And no, we can't step on it, and we're good to go. Okay, so let's compile and save that. And then what we need to do is we need to start wrapping our heads around how this is going to work. So let's take our box, right click on it and choose add event on component begin overlap. Now the idea here is when our character walks into this box, it is going to trigger this overlap event. And what we want to check to see is the other actor, the thing that is hitting this box, is it a top-down character? So let's cast this to, actually we don't even need to do that. This is where the interfaces come in. This is another actor. What we want to do is we want to tell the other actor to equip the item. Okay, but you'll notice that we can't equip the item. So what we're going to do is we are going to create a messaging system, just like we did for health, where this is going to be all about, hey, do you know how to equip items? Yes, I know how to equip items. Well, I'm sending you a message to equip the item, and that other actor will be like, sweet, thanks, I will do what I need to do with that. That's exactly what we're going to do. So let's see what we have for blueprint interfaces so far. Currently, we only have a health interface. So let's create a new blueprint interface underneath our blueprint menu. This is going to be blueprint interface, and I'm going to call this combat for now because we may be doing other things. I just need a generic one. And in here, for our first function, I'm going to call this equip. I'm going to be specific on this one. I could say item, but I'm going to go with weapon for right now. Okay, and all we're going to do is get the messaging service set up and working. So we now have a blueprint interface that understands how to send and receive messages to equip weapons. Now we need to tell the item, drop, and the character how to listen and receive those messages. So let's start with our item pickup. Our item pickup, if we go to our class settings under implemented interfaces, let's implement the combat interface, which is, like I said, it's just subscribing to the understanding of that messaging system. So now this character understands how to send a message to the combat messaging system called equip. So I can take this other actor now and type equip, and you'll notice that it has an equip weapon option, and it even has a nice little envelope for sending that message, which is cool. So we're gonna have to make a couple changes to it, but once again, we're just getting the service set up first. All right, if we go back to our top-down controller, our top-down controller has the ability to equip a weapon. However, I want to show you something. If we go into our item pickup, I want to get the display name on this. We want to check to see when we do this overlap, are we getting the controller or are we getting the pawn? And this is important because this determines where we will put this information. So in this particular case, let's go ahead and print string. And we're going to print the name of whatever this overlapping actor is. So when we walk over here, it prints top-down character. It is not printing the controller. So if you recall, our controller is the one that knows how to equip weapons. But the thing that we're overlapping is the pawn. So what we need to do is we need to bring up our pawn. And now there's a couple different ways to do this. I'm going to try to keep it pretty straightforward so that you all can follow along. Because we're going to be sending the pawn the message, we need to set it so the pawn can listen. So in the implemented interfaces along with health, we want to add combat. So now the pawn can receive combat messages. And if we compile underneath our interfaces over here, if I right click on equip weapon, I can implement this event. And now if I print string here, I can say pawn equip, for example. I'm not worried about the spelling right now, it's just temporary. Let's go back to our top down, let's go back to our item pickup and let's get rid of this print string. We don't need it, we know that that works. We can get rid of that, compile and save, and let's go ahead and play. And when we walk over this, we should see pawn equip. Okay, great. So we've got pawn equip, but we haven't actually done anything with it. So back in our top down character, there's a couple options here. We know, for example, that we could get the controller here and we could cast as an example. So if in here we get the controller, and then we cast this to a top-down controller. With that, we know that we can, with a top-down controller, we can equip a weapon. Okay, so this loop will work. However, the trick or thing to think about right now is when we equip the weapon, we're going to be equipping the exact same weapon every single time. Because in our top-down controller, equip weapon is always equipping split shot. So we need the ability to tell it what kind of weapon to equip. So here's what we're going to do. I am going to take this class and I am going to drag it onto my event. And what this is going to do is it's going to create a variable for me and it's called class. I'm going to rename this. I'm going to call this weapon class. Okay, so now we can specify which one to equip. However, we do have an error here. Let's refresh this node and let's plug this into the instigator, compile that. And we'll go from there. Okay, cool. So now that we have that, let's go back to our character. And our character is looking to pass this weapon class in, but we haven't specified it yet. So what we want to do is we need to be able to specify in our combat messaging system. We need part of the message to be the type of weapon to equip, the class of the weapon to equip. So what we're going to do is I'm going to add an input over here. And this is going to be weapon to equip. Or we could actually call it weapon class. Let's just do that. That's a lot less. A weapon class. And we want to set this to a weapon. And I'm going to move this over. So let's just move this over here. I'm going to set this to a weapon type base class reference. All right, let me move this back. Compile and save that. So now when we go to our item pickup, you'll notice that our item pickup now has a weapon class to pass in. So let's promote this to a variable. And what I want to do with this variable is I want to make it instance editable and exposed on spawn. And what that is going to do is that means that when I pick the actor in my level, you'll notice over here on the right, or I'm gonna drag this out so you can see it. You'll notice over here, I now have a weapon class option. So I'm going to set this one to split shot. All right. And then I'm going to specify for this one let's set this one to weapon base. So we now have 2 item pickups, one for split shot and one for weapon base. When we start our game, actually, let's finish connecting these first. Okay, in our item. So now that we have those exposed, these get passed in. We go to our messaging system. Messaging system sends that message to whoever's listening. Our top-down character receives the message and here's the weapon class. We want to pass that in. All right, let's compile this. We'll save all. Now, what we want to do for the ultimate test is let's go back to our controller and not equip a weapon to start. So we're just going to unclick this. So we're no longer equipping a weapon, and when we start, I cannot shoot. But if I walk over this guy, or this one, neither one works actually. So we missed something. Access none, trying to read primary weapon attached to. That might be a clue. Okay, so let's see what's happening here. When we come into our equip weapon, what I want to know is I want to print this string. Print string. Are we getting the name of the class when we do the equip? So let's just walk over that and let's see what we get. We get split shot and we get weapon base. So that part of it's working, which is good. So we know that's good. And then we come into our actual equipping of the weapon. And in here, when we did not, this is no longer connected. Interesting. Okay, so what's happening is because we're spawning a class, it does not know that the class of the actor that it's spawning is a weapon. So what we're going to need to do is we're going to need to cast this to a weapon. And with that, let's go ahead and connect this in. As long as that's successful, which it should be, we should be able to set our primary weapon now. Okay. So let's try that test again. We can't fire. We come over this one. We can fire, but notice that we're shooting from the origin. That's no bueno. Okay. And if we come over here, we are also shooting probably from the origin. So let's see what's happening here. Access none, trying to read property, spawn actor, preview, BP projectile, the weapon owner. That is being set on the weapon base. So are we not setting that? Spawn actor. Oh, we're not setting it. Okay. So we have one more thing we need to do here. In addition to setting our primary weapon, because the actor we're spawning, it doesn't know that it's a weapon base. What we need to do is we also need to set the weapon owner. So we're going to set the weapon owner, and the weapon owner in this case is going to be the controlled pawn. We just have to make sure we fill in all these values. So here's our weapon owner. We'll drop this down just to clean this up. All right, let's try one more time. That way our projectiles are actually shooting from where they're supposed to be. There we go. We got our split shot. Now we got our single shot. And if we walk back over our split shot, we got our split shot back again. Okay, a little bit of light debugging, but effectively, all we're doing is we have an item pickup. The item pickup sends a message, says, hey, some actor tried to pick this up. Do you understand how to equip a weapon? The actor receives a message, and if it knows how to receive that message, says, yes, I do. And then it actually equips the weapon for us. So we have successfully set up our game to be able to handle the idea of an item pickup, multiple weapons, everything. Now we do need to implement the idea of attack speed. Here's why. What I want to do is when we're actually shooting, right now I'm having to tap every time. This seems okay, but watch what happens when we make our game harder. If we make our game harder and we go back up to 5 enemies on each of these, what's going to happen is I am going to get destroyed really quickly. So what I'd like to be able to do is I'd like to be able to, yep, didn't make it. What I want to be able to do is, it's a twin stick shooter, man. I want to be able just to hold down the trigger. So we're going to set it up so that we can hold down the trigger. That's going to actually create an attack speed problem for us. We're going to be way too fast. So we're going to have to gate that with attack speed. So let's take a look at how we could potentially add, or the change that we can make so that we can hold down the trigger and then add attack speed to our weapons. So in order to hold down the trigger, what we need to do is we need to go back to our inputs, and under our keyboard input for the gamepad trigger axis, let's go actually to the input action. Let's see if we can make that change in the action. Input action primary attack. Here's what we're going to do. We have a digital boolean. The trigger right now is pressed. I'm going to change this to down. That simple change should make it so that when I walk over this, I can now just hold this down. Oh my goodness, like this game, we got this. Total victory. Okay, so that's pretty strong. And that's why I was saying we may want the idea, even, let's see if we can even do it with single shot. Come over here and get single shot. Can we win our game with single shot? I already won the game. Now, interestingly enough, even though I won the game, I'm still being attacked. So we're gonna have to take a look at that for a second. But overall, even with single shot, with infinite speed bullets, I can totally own it. So let's add the idea of attack speed. Okay, so here's what we're going to do. On the primary attack, which is in our top-down controller, let's see, where is that? This is where we trigger the weapon. Now, there's two places that we could potentially store this attack speed. We could store it in the weapon or on the character. I think I want to store it on the weapon because different weapons might have different attack speeds. So inside this trigger weapon, here's what we want to do. I want the idea of a variable called attack speed. And this is going to be a float. I'm going to set this to float. And then I need another variable for this to work. I need last attack time, which is also a float. So here's what we want to do. With our attack speed, if we compile this, let's take our attack speed and let's assume this is attack speed in seconds. I'm going to be very explicit with this. Okay, last attack time in seconds. All right, now when we want to attack, if we set our attack speed to be 1 every 1 second, I can fire a projectile. What I want to do is when we trigger a weapon, I want to get the last attack time. And I want, let's say at 10 seconds into the match, I click to trigger the weapon. At that point, that's 10 seconds. And what I want to know is I want to know if the last attack time plus our attack speed is less than the current game time. So what that means is if the current game time is 10 seconds, 10.5 seconds, is 10.5 seconds less than 10 plus 1? Yes. If so, I can't shoot. Now, let's go ahead and implement this. Sometimes I confuse myself when I save this stuff. So let's get to where we're going to. Get time in seconds. So we want the game time in seconds. This is what we're comparing. So is our game time in seconds greater than the last time we attacked plus our attack speed in seconds? And if it is, then we can actually trigger the shot. Okay? If it's not, let's just leave that empty for right now. Now, if it is and we trigger the shot, we also want to set the last attack time. And we're going to set the last attack time to the current game time in seconds. All right, so let's run through this logic really quickly so you all can wrap your head around it. Okay, press the trigger button at time 0. The last attack time in seconds starts off at 0. For example, 0 plus 1 is 1. Is the current game time 0 greater than 1? No, it's not, so it wouldn't trigger, okay? But assuming that you probably take more than a second, let's fast forward in time. Let's say we're at 10 seconds. Okay, remember when we start, the last attack time is 0. So is last attack time is 0 plus 1 is 1. Is 10 seconds greater than 1? Yes, it is. If that's true, we're going to set our last attack time to 10 seconds and we're going to spawn our projectile. Then we're going to come back through here, let's say at 10.5 seconds. Well, our game time is 10.5 seconds. Our last attack time is 10 seconds and our attack speed is 1. Is 10.5 greater than 11? No, it's not. So it's going to do nothing. All right, so this is a way for us to gate our bullets or our projectiles from being fired. So let's see what that looks like in practice. And I'll also show you how we can fix this. So as fast as I'm typing, actually, hold on a second. We're triggering the weapon. Okay, this is important. Look at what's happened here. When I go to step on this spawner, you'll notice that the middle bullet is firing every second. The two outside bullets are firing infinitely. All right, and that's because this is a split shot. And remember, a split shot does everything the parent does and then continues on. So we need to change the way our child inherits the ability to attack a little bit. So let's do this. Let's go back, and if this is true, here's what we'll do. Let's add a variable, and we're going to call this Boolean B can attack. We'll set this to a Boolean. And then what we'll do in here is we're going to set the value of B can attack to be the result of this. And then we are going to use B can attack as our gate. Now by doing this, we've actually created a Boolean that now exists in both the parent and the child. So if we go back down to our child, which is the split shot, after we do our call to the parent function, what we want to do is that same test. We need to check to see, can we attack in here? Because we're extending it. So let's go ahead and let's get can attack. And if it's true, we will go ahead and attack. And if it's false, we're just going to do nothing. All right, so now when we play, if we come over here and I hold down the button, it's every second. There's no way I can win this game by triggering this every second. So we need to set some reasonable default attack speeds. So let's take our default attack speed and maybe set it to 0.2, for example, on our weapon base, and let's see what that feels like. That's reasonable. Let's just say that this was a normal level. We'd want to start it out. Oh, I got caught up on that thing. I still got defeated. But that is a much more reasonable starting point from attack speed. And what we can do is we can basically customize this, and you can even create pickups that would affect and change the attack speeds of your weapons, for example, which is cool. Okay, so we've successfully implemented our attack speeds, but I wanted to show you a couple things. We have an issue where when we defeat, look at our victory screen shows up. So we have the victory bug. We have a couple little cleanup things like ear flicks that we want to get. So this next section is literally all about just testing and making some fixes that make sense for what we want our start to finish twin stick shooter mini game to feel like. So let's hop in, do a little bit of testing, QA, quality assurance, see what it is that we want to fix so we can put a bow on this little mini game. Here we go. Okay, so we know the victory thing is weird, but it's going to be hard for us to find. Let me go ahead and save all. It's going to be hard for us to find with our current camera. So I want to actually change our current camera to be a little further out. I find I'm struggling to see the whole map anyways. So let's take a look at our spring arm and our camera. And let's change this to, let's try 2000. Let's see if that is how that feels. Like I said, this is a little bit of polish. All right, that's better. I can kind of see what's going on. All right, so now that we can see what's going on, when we get defeated, oh, look at that. This is what's happening. Did you see that? The enemies
are destroying the spawners. So what's happening is they're spawning, eventually they accidentally trigger destroying the spawner, and if you recall, our spawners, when they are destroyed, that triggers the victory screen. So let's clean that up. So to do that, let's go to our enemies. Under blueprints, we have our enemy base. And remember, the way that that was being done was with this collision box. When this thing overlaps something, it triggers the damage. And because our spawners know how to listen to the health system, they receive the damage as well. But what we can do, I think, is we can just change it. Rather than overlapping all dynamic, let's, first off, we don't want to be able to step up on this. Let's change this to overlap pawn only. Overlap only pawn. Okay, and see if that fixes our faulty victory screen. And we'll know because we'll see, like, see, for example, how is that? Did I accidentally shoot that one? Nope, it's still being destroyed. So I guess that is, it is thinking that that is a pawn. So let's go ahead and do this a different way. So in our spawners, let's take a look at what our spawners are. Our spawner is, it derives from character. Okay, let's check to see when our enemy does the overlap, what is it doing? Event, do on begin overlap. It checks if the other actor is valid. Interesting. But for some reason, it shouldn't be triggering unless it's a pawn, but it is. Let's see here. If we change this collision to custom, world dynamic, block, I'm going to change this to ignore. I don't know why the pawn is block. So let's see what happens there. Does that do it? We should not see the health on the spawners depreciating. It's not. Okay, that fixed that. Great. So we basically just had to get our collision presets so that our enemies weren't inadvertently overlapping the spawners and they weren't taking damage. And you'll have to juggle this depending on whether your projectiles are supposed to hit the spawners or not, all those kinds of things. Okay, so there's a couple things else, speaking of cleanup. Once we hit the defeat screen, we don't want our game to keep continually to spawn enemies. At this point, game's over, stop spawning. So how are we going to manage that? Well, what I would like to do is in our spawner, we have our timers. These timers increment spawner counts. They do everything they do. We have spawner, this staggers our timer for spawning. What we need is we need a way for the game mode to tell us that the game state is defeat, for example. So right now our game mode does not have any sense of that. So let's go to our game mode and I'll show you what I'm talking about. Game mode. We have no sense of in here what the current state of the game is. So let's add one. And I'm going to add, let's go ahead and add 2 states, victory, defeat, and maybe, let's just take a look at this. All right, so here's what we need. We are going to create something called an enumerator. An enumerator is a way for us to use an actual string. It's a byte string to represent a byte so that we can visually see. And here's what I mean. It's usually just better to demonstrate these things. So if we go and we create a new enumeration, I'm going to call this enum game status. And in our game status, what we can do in here is we can add an enumerator, and this first enumerator is going to be called playing. For example, let's just make a couple different states. Playing. Let's add another one for victory. Victory. Let's add another one for defeat. Defeat. Okay, now that we've set these 3 variables, we can now use these 3 variables. So let's go to our game mode, and I'm going to add a new variable. This variable is going to be called game status, and it is going to be of type of our new enumerator. Game status. Okay, so when we start the game, All right, increment spawn count, event restart. Let's do, what do we have available for us under events? Add event. Event, let's go with begin play for now. All I'm going to do on begin play is I'm going to set the game status to playing. Okay. The other option I could do is not even do this on begin play. I can just set the default value for it to playing. Now we have a couple of things that we need to do as well. If we restart our game, we want to reset the game status. So we're going to set the game status to playing if we restart as well. Okay. Now what we need to do is when we win the game, we want to set the game status to victory. So here we go. This is where we win our game. This is where we're decreasing the number of spawners we have. This is where we show our victory screen. Let's set the game status to, you guessed it, victory. And then finally, the defeat happens, I believe, on the top-down controller. Let's check on our event graph. Event, oh no, it's on our pawn. Top-down character, because that's where we're affecting the health. So in our affect health, do affect health, we affect the health, that's inside of our component. And inside affect health, we come in, we do all these things. If it is a hero character, this is where we need to be. Okay, when we disable the input, we set our collision, we simulate the physics, this is all the Ragdoll stuff, then we go ahead and we flash up the defeat screen. Right here, what we want to do is let's get the game mode. And I don't believe we have a handle to the game mode in here at all, so we don't. All right, so what we'll do is we'll get the game mode, we'll cast this to a top-down game mode. And what I want to do is, if that is successful, I am going to go ahead and I'm going to set game status. Status, if I spell it right. And this one is going to be defeat. All right, so now that we've set all of our game statuses, this is being tracked. Now what we can do in our spawner, which is here, what we want to do is we want to set it so that if the game status changes, it does not continually respawn. It triggers basically a pause and invalidates all these handles, etc. So let's think about this. When this begin play starts, it kicks off a timer. We're going to need a handle to that timer. We're going to need that as a variable. We know this. So let's go ahead. And the way we know this is because we know we want to shut it down. So let's right click on this and promote this to a variable. And this variable we are going to name, this is going to be our spawn timer handle. Spawn timer handle. Okay, so we start, it triggers this timer. And this timer is looping based on our spawn delay. All we want to do is before we trigger our stagger timer handle is we want to see, or at the same time, we want to see if the game state is defeat or victory. Or we could also check not playing. So if it is, what we want to do is we want to clear and invalidate those timers. So here's what we're going to do. We are going to get our game mode, which we already have a handle to, which is great. We are going to get the status. Now what we want to do is we want to see if this is equal. Now when we do the equal, you have to make sure you pick the right one. You want to pick the enum equal, and if you do that, it will automatically fill in so you can pick from your nice pretty list. So if the game state is victory, or we also want to check for equals defeat. And that one I picked the wrong equal. It happens to me all the time. Equals. And then this one defeat. All right. Now what we want to do is we're going to do a branch. And if either of these two are true, victory or defeat, and I just said it out loud, that's how you know what to do. If victory or defeat are true, then we want to clear all of the timers and stop the spawning. So let's go ahead and do that. We're going to get this stagger handle timer. We're going to clear it. Okay, And then we're also going to get our spawn timer handle, and we are going to clear it. That way, our spawners are no longer spawning. So let's compile and save everything and see how we did. So first off, when we get defeated, what I want to see is I want to see that our spawners are no longer spawning any more enemies. Now, you could also do something like destroy all enemies. There's lots of different things you can do. I think it's kind of cool seeing the enemies still stomping around, you know, doing their victory dances, etc. So we got defeat, we checked that, that works great. Let's see about our victory condition. So here's what I'm going to do. I'm going to close down a few things, and I'm going to go back to ludicrous speed on the split shot. So under weapons, under split shot, I'm going to change my, this is split shot, right? Split shot, yes, compile. I'm going to change my attack speed to be 0.01. And I'm even going to move these pickups a little closer. All right. Let's go. Victory. Okay, now I want to hang out here for a second, make sure nothing spawns, make sure we have no defeat screens popping up, and then we need to test. If we restart, do our spawners restart? Yes, they do. Oh, they definitely do. Very cool. Okay, so I think the only other screen that we should probably double check is pause. So let's restart and pause. Okay, our spawners aren't doing anything. We can't do anything. Let's resume. We're shooting. Pause. Everybody pauses. Our projectiles pauses. So I don't want to jinx it, but I think we're almost done. So before we put a bow on our twin stick shooter, I do want to mention one last thing as to why we moved our weapons to be their own actors. And the reason for that is, imagine right now when we started, we only had one weapon. Imagine fast forwarding and you have 20 weapons, but you're only using one at a time. Well, the thing is, you have to still load, if all of those are part of your hero character, you have to still load all 20 of those weapons, plus all of the abilities and everything that go with it, even though only one of them is being used. That is not a very sustainable way to build. So the whole reason we went through this exercise of being able to add weapons as a separate item that we can pick up and equip and do something with is because we're trying to future think. And that's what this entire mini game was about. It was about giving you a start to finish twin stick shooter mini game to start to introduce you to the ideas of all the various aspects that go into it. And at the end, you actually end up with a very cool little mini game that you can tweak and add on and learn from. And we may even be using this in future tutorials as a baseline, because everybody will be able to just hop in and build their own version of it. And we can talk about performance testing and how do we handle abilities or secondary weapons or any of the other number of things. So that's it, y'all. One twin stick nostalgic mini game shooter tutorial. As always, your feedback is huge. Throw all your comments down in the comment section down below. If you went through this tutorial, you got your own little mini game running, go ahead and hop in the Discord server. Share your win, share your victory. We would love to see those kinds of things. And again, if you dig what we're doing here, there's lots of different ways to support the channel. I talked about those about 5 hours ago or however long it was ago. We have the tips down below, we have the Patreon, we have the super chats and thanks. Helping spread the word is huge. It's all goes towards making this channel sustainable and creating more future content for you all. My name's Kevin. I'll see you on the next one. Take it easy.